Hello and welcome to this captivating course of Updegree, Blockchain for Financial Professionals. Hey, I am talking about financial assets and blockchain. In this session, we will be talking about how financial assets actually led to the blockchain technology. The first module, what we are going to talk is blockchain primer. In this section, we will be dealing with the basics of financial institutions and what are the account practices. This is very important because we will be transforming the journey from a typical legacy financial technologies to the modern technologies, where we will be discussing about how blockchain is actually transforming the whole financial sector. In this journey, I will be sharing the practices and some of the components that is really required for any individual to learn and master the blockchain prima facie for the financial services. So you will be learning certain key accounting practices that is currently prevalent in the market and how blockchain is disrupting the whole space. Before, we need to understand that blockchain is categorically going to be called as Web 3.0, and which will be mainly focusing on the three things: immutability, scalability, and transparency, and bit security. I'll be touching on in the further modules on how blockchain as a key technology will transform into the financial world. With that, I would like to start this session. So most of you might be understanding that what is business networks, markets, or wealth. So if you really look at it now, businesses don't exist in isolation. That means I start a company, I'm not alone. I have to get connected to customers, suppliers, banks, partners through the business network. And this network is also cross-geography, regulatory, and it's also bound by certain rules and regulations. And what do you mean by wealth? We all know that. It's basically some total value of goods and services across business network. And growth alone, constrained if siloed, is not efficient. So basically, we need to have what is markets, because markets is essentially flow of goods and services across business network, where there is an open market and where there is a closed market. So this you might be already aware of in the financial world. So the second concept which I would like to bring in is transferring assets and building value. What is asset? Anything that is capable of you own it or control or produce it is considered an asset. So it can be a tangible or it can be an intangible. It can be value or it can be converted into cash. For example, in the right hand side you see a car as an asset, or cash is also an asset. So you have a car, you have clothes, you have bonds, you have securities, you have patents, you have licenses. Now you have digital assets, music, video, games, patents. These are some of the digital assets that's kind of built. So we need to understand what are assets and we need to build value into the assets. So when we have financial thing, we need to understand who are participants, what are transactions, and what are contracts. Participant is a member of business network who may actually be a customer, a supplier, or a government, or a regulator. He usually resides in an organization and he has specific identities and roles. So what is transaction? A transaction is an asset transfer between two or more participants. For example, there is a transaction when somebody is buying something or somebody is transferring something. So basically John, as an example, gives a car to Anthony, or John gives car to Anthony and Anthony gives him the money. Very simple. There is an exchange of goods and services. So transaction is basically a asset transfer between two or more participants. So what are contracts? A contract is a set of conditions under which transaction occurs. For example, if Anthony pays John money, the car passes from John to Anthony. That we are already aware. If car won't start, funds do not pass to John, because it should be adjudicated in the sense like if the car is not actually working, then there is no point in having a contract. So this contract is valid only when car is functional, and then only Anthony pays money to John. So we have seen what are transactions, what are contracts, what is the basic value of an asset. So this is what we actually anticipate. This is the classic fund distribution. This is a classic fund distribution value chain. You have three layers. Basically, you have a distribution network, you have asset servicing, and you have a portfolio manager. So in terms of what is distribution network? A distribution network is where people use, they are the people who are like an intermediary.
So they can be investors, they can be distributors, there can be companies, they can be promoter, or they can be domiciliary. And there are a lot of asset servicing people. They basically take care of the paying of agent, custody, accounting, and there are typically portfolio managers who actually have auditing, tax. They take all these in the value chain. And on the right side, you will see investment fund and the supervisory environment. So basically, you have a 3-layer structure, and this whole chain works. It is end to end, and each one is dependent on the other one. So it's a simple one, but at the same time, you have multiple partners to make sure that the value chain is not broken. So what happens? I am an investor. The current transaction process is this: I have an investor, I have a distributor, and I have a transfer agent. What happens is, as an investor, I will apply for AML KYC, that is anti-money laundering or know your customer, and he applies again AML KYC, and an account is created, and typically then the flow starts. That's how your dollar gets processed. So as an investor distributor, make sure that all the documents are clear, and then he will open the investor account, and then he will ensure that all the checks and balances are there. And the current settlement process, similarly, if you need funds, you just have to go to the paying agent, you request him, and there is a custody which is there, which is getting approved, and you get the funds back into your account. So this is the current settlement process. And current financial process, everybody in the system has to be important. You have, whether you are an investor or a distributor or a management company, whoever is promoting, they need to have a complete financial reporting process. That means end to end, whatever the financial transaction happen has to get applied to government bodies and also the financial reporting agencies. So what are we doing as being financial institutions? A very good question. So there are a lot of questions, right? Because ultimately this whole learning is in terms of blockchain and cryptocurrencies and how blockchain helps. So there are a lot of questions. Please explain me how Bitcoin works. What is the role of a typical managers in the blockchain? Somebody is talking about whether we should bring or build a blockchain. And is there anything that has a storage that you require, like a RAM, or whether she understands how the trade can get done through blockchain? These are some of the questions, that is going in all our minds. And there is a good opportunity for professional services firms that rely on consulting, accounting, and auditing can actually get changed or transformed and help the clients, using blockchain. In other words, one of the key ways to reduce, there are a lot of research that has shown that, financial institution wants to reduce costs, that everybody is aware. So one of the survey according to Deutsche Bank in 2012, they have actually cut down, measured as a percent of the revenues, financial firms spend more than on IT on any other industry. So, the financial companies are spending equal to 7.3% of the revenues, otherwise compared to other industries, which is 3.7%. So how much of the dollars gets invested in the IT sector. So it's easy if you have a kind of a balance and then see if the new technologies can actually reduce the cost across various cost centers. Even there is another one, from 2015 from Celentis, that from total bank IT spending across all the regions is put together in $197 or $198 billion, and it's growing at a minimum of 5 to 8% year on year. That's very stupendous. So there is one report from Santander. Santander, as you know, is a leading bank in the UK, and they, according to predict that distributed ledger technology or blockchain could reduce banks' infrastructure costs attributable to only cross-border payments, security trading, and regulatory compliance between 15 to 20 billion. Like for 200 billion, you are cutting the cost by at least 10 to 12%, which is stupendous. So as an accountant, why it is important? Important because accountants are the key guys. They are the people who implement, settle, and store records around blockchain. So accountants will need to know how audit records are shared between, I'll come to you on the permissioned and non-permissioned ledger later. For example, an auditor should, an IT account or a financial accountant should know, the auditor should know how they should audit infrastructures, banks, and how they can be ready for the future. So this is one of the quote from Huckman Lab, which is one of the good labs. So accountants should need to understand the technologies because they are the lying people who actually understands the records on all blockchain and accounts and auditing and reporting. So they have to be very key in this whole value chain. So this is what we have learned in the first section as icing on the cake is what is finance, what is transaction, what is contract, what is the value of a contract, what is a goods and sales marketplace. We also understood why it is important and why banks or financial services need to be focusing on their part on technology.
That's all for the session. So I hope you have enjoyed the first session of the course. In the next session, we will introduce the distributed ledger, that what is distributed ledger, how it works and everything. Thank you. Hello and welcome to this distributed ledger session.
As icing on the cake is what is finance, what is transaction, what is contract, what is the value of a contract, what is a goods and sales marketplace. We also understood why it is important and why banks or financial services need to be focusing on their part on technology. So in this current section, we will be deep diving, or we'll be at least discussing what is called as distributed ledger. You have seen a quote from Santander Bank, like it saves 10 to 12% of the cost. So here we will be looking at what is distributed ledger and a couple of the distributed ledger related terms. So distributed ledger technology is actually a centralized, decentralized and distributed databases for data storage. So it's one single term. It's a decentralized and distributed database for data storage. So basically, what is blockchain? Blockchain is a form of distributed ledger technology. So what happens is blockchain is distributed across many nodes. So hence distributed ledger, unlike most databases which are centralized. And the second key point is the blockchain in each node is generated based on the information publicized from the successful mining node. I'll explain. So unlike the traditional centralized databases, there is only one or maybe couple of databases that gets managed centrally. But whereas blockchain is a distributed ledger where you have multiple copies stored in various forms and it's completely decentralized. And it keeps coming only when there is a successful mining happening in the block, and then they will understand. And this is based on the permissions given in the ledger. So it is quite useful for people if say in terms of hacking, right? Most of the databases get hacked, but in case of blockchain, if somewhere it goes out, first of all, entering this network is little difficult. Second, hacker cannot, even he stores it, he hacks the data, you have multiple copies of the data. So distributed ledger technology is a distributed data store based on each node generated through a permission in the blockchain network. So that is what is distributed ledger technology.
So that's it. I hope you got a basic idea of distributed ledger. In the next session we will deep dive into the distributed technology in advanced level. Thank you. Welcome to another session of distributed ledger. In this session we will know more about the distributed ledger technology. We will get an idea about centralized and decentralized ledger. So let's jump to the discussion.
So now you see how is the difference between centralized and decentralized. Examples like some of the key things is the centralized ledgers, you have a lot of cost associated with, whereas in terms of distributed ledgers the cost is very less, that is maintenance cost. The intermediate cost, that means the cost of involved in having the trusted third party is less in dollars in terms of centralized ledgers. In terms of distributed ledgers it's a little high, but then you cut across the intermediary layer. Then transparency, it's centralized ledger anybody can view, but distributed ledger is safe because you have very few people to view the ledger. Security, you can easily have a difficult fraudulent transaction, malfeasance and example in the centralized ledger, whereas in distributed ledger it's much secure. So overall, your maintenance cost is less, though your initial investment may be a bit high than the it's equally in compared to the centralized ledgers, but you have a better transparency and security. So why distributed ledgers? There are many reasons. The reasons why organizations and institutions are interested, because the biggest advantage is it is cryptographically verifiable system, and it's globally distributed for resiliency and compliant with various reporting requirements. So distributed ledgers, have you seen, you have multiple copies. it has transparency, it has better scalability and security, and that's why financial institutions want this on a regular basis. So please understand that distributed ledger technology is the future, and it all started with what we call it as a Bitcoin. So this is the cycle. So what happens is, there is in terms of technology, you can actually create a distributed virtual machine, and it forms a blockchain. And when the blockchain is happening, if there is a transaction, the network achieves settlement to the transaction, and then finally the assets is transferred through smart contracts. So I'll explain what is smart contracts in a single line. A legal software code between two parties, that is receiver and the sender, through a legal line of code, which is an alphanumeric or a hash characters, is called as smart contracts. And the smart contracts has wide usage. It can be used for assets, any of the assets, for sign off. So it's a very simple thing. You have a distributed virtual machine that gets created. There is a permission algorithm that runs on the distributed virtual machines, and then once you have network it got matured, then you get sign off with the smart contracts. So centralized ledger, we have already discussed. There is a trusted third party, and central authorities certify ownership and clear transactions. Whereas in distributed ledger, it is no need of central authorities. The entire thing is done by network of institutions. So you have 40 banks. You will have to go to a trusted third party. You just have to do the certification through the institutions, and there is no one which is in charge to just go through the thing. So it's going to cut down the whole intermediaries in the process. So that is the biggest advantage. So why distributed ledger technology? It has encryption, it has mutual consensus verification, and it has smart contracts. So encryption, I have already told, it's a two-layer technology where your entire digital assets gets saved. There is a consensus. That means like there is no central party. It's a consensus between the people who are in the network. And smart contracts, a single line of code, single line of software code legally. So it is very easy. That's the first advantage. Second, data efficiencies. You have universal data source. You don't have a particular one single data source, or a ledger which is owned to somebody. Unlike you have a distributed databases coming across the whole enterprise or the whole ledger. It has rich data sets. Because you are using the latest technology, the transaction speed is very fast. The third is, you have distributed records. So unlike the records are available with one or two copies, here you have multiple records of copies. And finally, what are the benefits? You have transparent real-time data. Of course, you get real-time data with the legacy technology, but here you have transparent real-time data. So just understand the point: transparent real-time data. And second is, it gives you a more efficient settlement of transactions and processing. Please understand that the core, more efficient settlement of processing of transactions. It's faster, it's time, it saves little time, and is cost effective. So why distributed ledger technology, and why financial organizations have to go? It's a technology innovation. It has data efficiencies, and it has better benefits. So again, you have a ledger. We have already seen like the whole ecosystem as a circle diagram. Now you see, like, once you create a ledger, it creates block 1, block 2, block 3 till block n, and you have this transaction record which is attached to each block, or it can be attached to multiple blocks. So if you really understand distributed ledger technology, basically that is the generic name of technologies pinned by a distributed ledger, where like Bitcoin and blockchain kind of applications are available. So if you grow the ladder, it is like either blockchain, or there are other distributed ledger technologies like Hashgraph, which is coming up in a big way. And the biggest use case of distributed ledger technology is the virtual currencies or the cryptocurrencies. This is actually underpinned by blockchain platform. So you have a lot of virtual currencies or digital currencies. For example, Bitcoin, Ethereum, Ripple, and you also have other altcoins. The coins which are outside of Bitcoins are all called as altcoins. So these currencies are called cryptocurrencies, and they are actually pinned by the blockchain. So if you take the real bottom up, distributed ledger technology is the generic name. it has two components, blockchain and other distributed ledger technology, which is hashgraph. The biggest use case for distributed ledger technology is cryptocurrencies, which is underpinned by blockchain. We have not seen any cryptocurrency based on the hashgraph as of now. So hope you are understanding why distributed ledger technology is becoming more popular and popular through these slides. So in one of the surveys with the distributed ledger technology in financial systems, they understood that at least in last 2 years, awareness of DLT has actually grown rapidly. Because the reason, if you see this slide, it is actually activity oriented. So there is a whole global interest. So that means more than 25 countries. This is little outdated, but there are more countries investing in DLT. There's a lot of banks which is experimenting distributed ledger technology. And there is a venture capital which is seen like $1.5 to $2 billion already gone into the blockchain. And many of the central banks, JP Morgan to everybody, are using this distributed ledger technology. There is a lot of consortium efforts. That means you have a effort like Hyperledger, which is a merger of 40 different companies and coming in investments in this. And you will see 2,500 patents filed in over last 3 years. That means it's growing rapidly. There are a lot of collective standardization efforts, and but then it's kind of getting into a formal legal framework, but it has to get captured in a much better way. So, but you see this slide, distributed ledger technology, as we have seen in the earlier slide, there are two kinds. One is blockchain is a main, and there is newer technologies like hashgraph. But at least in the blockchain area, you are seeing these kind of data points. It's just for information. That just shows the curiosity how the entire industry is moving towards the whole ecosystem.
That's all for the session. In the session, we'll learn the potential for financial applications in distributed ledger technology, and it will be going to be very interesting. Thank you so much. Chapter 4, Distributed Ledger Technology, Potential for Financial Applications. Welcome to the third session of Distributed Ledger, and in this session, it belongs to Potential for Financial Applications and Distributed Ledger Technology.
So why do you need distributed ledger technology, and why it is important for future of financial services? So DLT has got great potential to drive simplicity and efficiency through having an optimization of financial services infrastructure and process. What I mean to say is your intermediary layer is cut, you have real-time settlement process which is transparent, and you have seen the other benefits. You have the data processing time is also reduced. Of course, DLT is not a panacea, but this is one of the main technologies that will form the foundation of next generation financial services infrastructure. Already cloud is leveraged by banks and financial institutions. Now they will build blockchain as the next level of financial information infrastructure. But the third point which I want to deal is that the application of DLT will actually differ by use case. For example, this can differ from trade finance to corporate banking to probably trade settlements to how share market. So it has different ways. You have different use cases, and it has diverse range of benefits. And the reason why it is is because the whole digital assets is using digital identity, and it's a critical enabler to broaden applications to new verticals. And digital fiat legal tender, because you have seen blockchain using smart contracts, it has amplifying benefits. But you need to have a caveat here. The most important is you will have to have deep collaboration between incumbents, innovators, and regulators, and adding complexity and delaying implementation. So you need to be very frank. Is it required or not? If it's required, let's have a plan. So one of the main advantages, the correct orthodoxies which you believe in the traditional business model will go away with distributed ledger technology. So it is very simple. It drives simplicity. It is efficient. It cuts across the next generation financial services. Any use case in the financial can actually use it, but you have to weigh the advantages. And since the whole world is moving to digital, you need to have a digital identity, especially the security part of it. And you need a legal tender which is digitally acceptable. And blockchain believes and gives you that snapshot. And it clears away the orthodoxies that is kind of available in the today's business model. So there are main 6 key value drivers which I have actually used in this. So regulatory efficiency improvement, that's one. because DLT enables real-time monitoring of the financial activity between regulators and regulated entities. It's already available, but it will more increase the efficiency. The second is operational simplification. It reduces manual efforts to perform reconciliation and resolve disputes faster. Counterparty risk reduction. It's very important because you have a lot of counterparty. Like, you have to agree, disagree, obligations as agreement, but here it's all immutable and it's codified and this is foolproof. Liquidity and capital improvement. That means like reduces the locked-in capital and provides transparency into the sourcing liquidity for assets. One of the important ones. Then we already discussed clearing and settlement time, because you are cutting away the third-party intermediaries. Actually, it validates and accelerates the settlement faster. And finally, you have fraud minimization, because you know who is a single source of truth. It enables full provenance, and you can actually track the history. Not that it is not trackable now, but it has more efficient processes embedded within the distributed ledger technology that makes it little popular for new financial infrastructure and processes. So this slide, essentially we are talking about distributed ledger technology has potential to drive simplicity, and what are the 6 value drivers. As I said, if you need to identify use case, for example, I'm using a trade finance, just look at these benefits and then you can start your use case for distributed ledger technology migration. So you have seen, like, lot of technologies have emerged in the last 50 years. So you are currently seeing the emerging technologies in like starting Industrial Revolution 4.0, being biometrics, cloud computing, cognitive computing, machine learning, quantum computing, robotics. So again, in these entire thing, distributed ledger technology is one of the many transformative technologies that will shape up future services infrastructure and should be certain seen as a part of toolbox. As I said, it's not a panacea, but it is one of the emerging technologies that will form the foundation for next generation financial services infrastructure. And second thing I've already gone to is this, digital identity is a critical enabler, because the future innovation actually goes on to the digital identity. So you need to move from the current state. So you have seen current state, current capability enabler, and future benefit. So this is how the concept has been built. That means like you need to identify who is the person who is actually identified for transferring the information. Be it protocols, be it cash, be it any of the storing information or transferring information, transferring assets, doesn't matter. You should be actually using the digital identity in a proper way. And the benefits why I need digital identity, because it actually gives you the accurate anti-money laundering and protects the KYC, and customer onboarding is faster, and it actually improves the counterparty matching. So the current state, you have digital DLTs are denominated with tokens, but with the formalization of the financial structure, you will have more distributed fiat currencies. That means like you have a single source of currency that can be settled within the one ledger. And tomorrow's world, maybe you have a single bank throughout the world, and it is all run by distributed financial infrastructure and cutting away the whole intermediary layers, whether it is between any country in the globe. So digital identity is very key, and digital fiat is one term which you need to identify. Fiat currencies are the normal cash. So digital fiat will be the new normal as a legal tender for currencies. And future maybe like you are looking at a complete alteration of the financial system where it will be like a single world, where the distributed ledger technologies can actually replace the whole intermediary layer. So, but yeah, the benefits are many. We have to wait and watch how the whole thing amplifies.
Here is the end of the session. Next, we will see how we can develop financial distributed ledger technology or DLT. Thank you. Fifth, how to develop financial distributed ledger technology. Welcome to this session, and this session is going to be about developing financial distributed ledger technology, or we say DLT. So let's get started with the session.
Once you know something is coming, the most important thing is it requires deep collaboration between incumbents, innovators, regulators, and also avoiding complexity and delaying implementation. So some of the thing is, it's a mix of three things. Why it is important, because DLT will have its own advantages, but then you need to have three things into the whole structure. First, you are replacing the infrastructure replacement. Second, there should be a competing interest, and third, it should be supported by legal, regulatory, and governance framework. Very, very key. So in terms of infrastructure replacement, you are actually moving away from the traditional model, and it will require significant time. I can give an example in the old days, like when enterprise resource planning came, where there were disparate applications. Actually, ERP linked the whole organization. Typically here, you are linking the whole ecosystem. So that's the kind of a change. Second, competing interests. It's like, you should have a collaborative actions between the ecosystem. That means like a supplier or a manufacturer or a customer, everybody should be in buy-in with the whole competing interest. Then implementing is easy, but then you need to have an approval. Regulation is key, and governance framework should be defined, and it should be actually acceptable legally. So that's the key that actually, which is very key in terms of, achieving the impactfulness of the distributor ledger technology. And in one term, it should be collaborated. It should be innovative only when you have all these three elements getting tied together. So in this concept, it's very important. The current state, there are information silos. There is a single version of truth. There's an asymmetric information between markets. There's no transparency sometimes, and there are lack of trust. So these are the transformative characters which distributed infrastructure will bring in. I've already told this. It's immutable. Then it's transparency, and third is autonomy. So you can understand immutability, transparency, and autonomy. I'll just give you. Immutability means it eliminates the need for reconciliation. It just provides a single version of truth. Transparency means it eliminates imbalance of information between the participants. It increases cooperation between regulators and regulated agencies. And autonomy, as we already discussed, has to be governed within the ledger. There is nobody who is going to manage it. It runs on its own, so it is completely autonomy. So there are entities who should resolve disputes by themselves. There is no agency. Yeah, it is covered by a legal framework, but then the adjustments have to be made within the ledger or within the distributed ledger ecosystem. So the transformative characters I am again summarizing. It is immutable, it is transparent, it is autonomous. And so it needs, and why financial services will use it? Because it eliminates the need for reconciliation. It gives you an imbalance. It actually takes out the imbalance of information among market participants, and it's actually executed within the intermediaries, and there is no need to have a central authority. So that's why your financial services actually is important to adopt distributed ledger technology. Yeah, so one of the current state is this distributed ledger technology will question the need for individual books of records through immutable and distributed record keeping. This is one of the very important things. The DLT provides, I've already told, transaction immutability. That means a key requirement of enforcement of trust. That means like the tamper-proof of data, in which trust is not an issue and allows counterparties to just operate with single version of truth. Currently, assets and transaction information is stored within physical books, current state, and some physical books are actually accessed, but even you have digital ledgers which is accessible by many people. There are a lot of issues like, you can actually copy the book of record and then you can just sell it at some money because at a fraudulent transaction. But if you see the core of distributed ledger technology, you have multiple copies. It's actually you have participant nodes. You know who is coming and approving it, and that's the potential. So why financial services will go for it is it actually challenges the information silos. It actually gets down the intermediaries, central intermediaries, and reduces for the arbitrage within the ecosystem, and you have complete tracking, one-to-one tracking in the whole ledger, and so it becomes tamper-proof. Counterparties can just go operate with single version of truth, and it's kind of having an enforcement of trust in the ecosystem. So one of the key things that you can actually see in the whole distributed ledger technology, and that's why when you have such technologies, the second point we need to identify is it increases transparency between markets. So the current state is that it's completely fragmented. That means like you have a varied degrees of transparency. As a result, some actors within the ecosystem will have competitive advantage based on the sometimes title, sometimes power, sometimes money. But distributed ledger technology will bring in that transformation potential. That means like it provides full transformation transparency into transactions. it has potential to transform private records into ones which is actually promoted within the ledger, and you can promote the creation of public record, because here there is nothing on private. The people who are going to be in the distributed ledger technology will have access to all market participants, or it's all real time. So you will know who is going to access, because everybody is in the same page. So why financial services? Because so existing competitive advantage model will go off. It reduces the role of supporting entities. That means there is opacity within the ecosystem. There are few folks who are getting profited from it. So this will kind of completely reduce that. And third thing is it actually brings in a transparency between market participants, and there is something, no secure personal identifiable information data. It's very important, right? When you have an enterprise data, it becomes sometimes like personally identifiable data. So you are removing the actors, you're making it seamless, you have a transparent system, and you are removing that information asymmetry. So these are the ones which is very important for any financial services. That's why distributed ledger technology brings in sharing information among all market participants, and it's built on single version of truth to provide transparency for historical and real-time transactions. The other point which we discussed is it reduces the information asymmetry between borrowers and lenders. That means DLT enables improved visibility into the ways in which assets are being employed through the tokenization of assets and public record. The current state here, you see you have a varied forms of transaction times, be it loans, be it pledging, be it asset management. And there are limited line of sight between the borrowers, between the debtors, between the creditors, and who are creating an asset value. So this opacity is actually creating a lot of reputation factors, and some of times even after rating agencies gives you an idea how it has to be done, still it has issues. But why distributed ledger technology is actually you can tokenize individual assets specifically to a trusted ledger. That means you can have a single line of code like smart contracts, and you can make this available in the system where all the market participants can get access, and it increases the efficiency of credit transaction. So why financial services will go for it is it promotes visibility of assets, it reduces to capital for borrowers because it limits the use of same asset to leverage from multiple parties, and it challenges the role of the current entities in quantifying risks. So distributed ledger enables improved visibility into the ways in which assets are being employed through the tokenization of assets and public record of transactions. So I'm just giving 7 principles of the distributed trust using blockchains. It would be inaccurate to label blockchains as a tool for intermediation of trust. In reality, they are enabling re-intermediation of trust. So try to understand. They are building trust. They are building original trust, single truth of trust. And blockchains enable a single degree of trust unbundling. The whole change is actually transformative, and it reassigns some of their responsibilities, sometimes weakening the current authority. The blockchain does not eliminate trust, but it shifts, it moves around. So trust is always needed, but with blockchain it is delivered, it is earned, and it's a technology. So it brings in that singular, it changes from the multiple into a singularity way. It's easy to authenticate. So the blockchain actually disrupt the existing economics of trust, because the cost of delivering such now are distributed. Whereas if you really take the central distributed things, brings more trust rather than creating more confusions. So it's a shift. It's like you have to earn the shift. You have to become more authenticated with the shift, and it's delivered through relationship and trustless among all the powerful entities within the blockchain. So with that, there are 7 principles which I have covered. So we have seen what is distributed ledger technology, what are the benefits, how technology can enable, and why decentralized trust using blockchains are key. With that, we will be also focusing on much more on the distributed ledger technologies in the coming modules.
So that's all for the session. After that, we will consider some blockchain principles and blockchain business rules, transaction processing rules in blockchain in the next session. Thank you. Sixth chapter, blockchain principles. Hello and welcome to the session. In this session, we will understand about blockchain principles. So let's jump to the blockchain principles. So in continuation, how blockchain will disrupt the financial industry, we will see in this section of what is blockchain principles and basics. And as we discussed in the earlier slides, what is distributed ledger technology and how it fits into the decentralized model. So we'll have some kind of understanding how it fits into the decentralized model. As I said, Bitcoin is the first blockchain-based cryptocurrency, and the blockchain principle started with Bitcoin, and it's a part of the decentralized ledger technology. So if you really take 2016, most of us are aware of the hype cycle. This is actually given by Gartner, and if you see the curve, the sigmoidal curve, you see the blockchain is in the top, in the sense like it is going to stay. It's going to be very mature in terms of next 5 to 10 years. Like that means like 2016 or 2017 to 2027, there is a huge requirement. Blockchain will be disrupting the whole environment. Though you have a lot of technologies that is coming through, but this is one technology is in the growth phase, and it's going to continue for next 10 years at least, minimum of 5 to 10 years before it gets plateau. So how did the blockchain start? So this is as we discussed, like Bitcoin is the first blockchain-based use case, and it all started with this small 8-page white paper, which is telling that it's Bitcoin is a peer-to-peer electronic cash system. That means it's a system of electronic transactions without relying on a trust, and laid down the working principles of cryptocurrency. So this is a white paper by Satoshi Nakamoto. We don't know the actual physical person who is he, but he was the person behind. He or she was the person behind this Bitcoin. And what happens is, the purpose of the solution was to ensure that the payments can be done from one party to another party without having any kind of intermediaries or any kind of approval or trust. So this whole transfer of payments from one happened to electronic code or software code, and that relied on a chain of transactions. That's where your blockchain started, and this transaction was stored in many nodes, multiple copies, and that's the longest chain. So the basic blockchain came from the Bitcoin use case. So to just summarize, blockchain technology was first introduced in a white paper entitled Bitcoin, a peer-to-peer electronic cash system by Satoshi Nakamoto in 2008. So what were the features? It was based on no reliance on trust. It was completely based on digital signatures. I did explain about peer-to-peer network. That means you have multiple nodes that gets connected in the blockchain for multiple copies of the same records. Proof of work means there is an approval mechanism within the system. You don't need proof of work means the transaction is actually executed, and all the transactions can be shown publicly. It shows, and it's honest, intermediate, interdependent nodes, and it's basically based on the computing power. So the nodes vote for the CPU computing power, and rules and incentives are actually enforced through consensus mechanism. I'll explain how the 51% that is required for a Bitcoin transaction next for this slide. But this is how the fundamental things are. So blockchain technology was entitled. So if somebody asks, it's basically started with the electronic cash system by Satoshi Nakamoto. So based on this, there's a definition. Blockchain technology is a digital innovation that is poised to significantly alter financial markets with the next few years within a cryptographic ecosystem that has the potential to also significantly impact trusted computing activities and therefore cybersecurity concerns as a whole. So what is it? It's a digital innovation that significantly will help financial markets with next few years within a cryptographic ecosystem, and it has a potential to impact trusted computing. That's where the fundamental business runs in financial. So that's about blockchain. So this is just for information. Earlier digital currencies had a problem of preventing users from double spending. That means like one person spends buys something, the seller gets the money, And seller also uses the same coin or currency to buy something. So it was a double spending problem. The same code was there. But actually, Bitcoin solved this problem with a lot of maths. We will just cover this in a while from now in the next few chapters. So phases of blockchain innovation. So what does it add? It adds business value, adds services. So there are a lot of applications that is built on blockchain. These are embedded transactions, collateral networks, conditional payments, smart contracts, and so on and so forth. Overlay services, you build application, but then you need how transaction has to happen. So this includes wallets, exchanges, consumer merchant services, and Bitcoin. And apart from currencies, you have from Bitcoin, there are a lot of altcoins that is in the market. So any coin apart from Bitcoin is called altcoin, and they are in the initial stage of blockchain fabric technology. So what is blockchain? More formally, it is referred as the distributed ledger system, where participants participate in a network of database of transaction shared on a real-time basis by the parties in the group. So the network itself verifies the transaction through a consensus mechanism. That's how you can see the picture. A set of rules governing the process of agreement within the system. As blocks of transactions are verified, the blocks are logically and irrevocably linked to the one before it. So very simple. There is a distributed ledger. Participants in the network create a database of transaction. Once the transaction is approved through a consensus mechanism, a block is formed and the block is verified, and the blocks are logically grouped and linked to one before it. So that's what we call it as blockchain. So how it is bit different from unlike the centralized ledger system? This is a decentralized one, which can be copied and updated by a number of parties, with all parties copies being identical. This peer-to-peer linked transaction is embedded within them that it becomes a computational point to modify the data once block is created. So you don't. The biggest power is that once you have created the block, it's impossible to modify or change. So this is a very great innovation, as a system. So why we are looking at blockchain? You have typically three levels of blockchain. So one is storage of the digital records. Second, exchanging digital assets. So that means like you can exchange tokens, coins, currencies, points, anything, or you can even exchange records like land records or. And third, you can execute smart contracts. Smart contracts, I explained earlier, it's a single line of code which is legally accepted. So that's easily identifiable with the blockchain. So ground rules is like the terms and conditions are recorded in a code, and distributed network executes contracts and monitors compliance, and the outcomes are actually automatically validated without third party. That's the beauty of this blockchain. Outcomes are actually automatically transacted without any third party interference. So distributed network executes contract and monitors compliance, and outcomes are automatically validated without third party. So this is the blockchain process as a diagrammatic way. What happens? You saw a user request a transaction. A request is transferred to a peer-to-peer nodes. Nodes verify the transaction with a computer algorithm. The winning node groups transactions. This forms a new timestamped block of transaction. This is added to the blockchain on to the all the verified previous verified blocks, and transaction is completed and the ledger is updated. Very simple. User transaction starts. Request is go to a node level. Nodes are verified. Blocks are arranged. Blocks are timestamped, and then the approved block is getting added to the previous verified blocks, and transaction is completed and ledger is updated. Say like there's a use case. First example is like generically told, but typically if just understands, A wants to send money to B. So what is here is the transaction is represented as a block online. So the block is broadcasted to every party in the network. So that means like here the money is kind of approved in the fourth step. The network approves whether the transaction is valid. And once the transaction is valid, it can be added to the chain, which provides an indelible and transaction. And finally, the money moves from A to B. Simple. Earlier I just told generically, but this is the money A to B, and that's how it is being transferred. So it's a very simple thing. It's a disruptive technology. We just need to understand how it works. So blockchain in a nutshell, it's an up and only system of record shared across business network. That's a shared ledger plus all parties are agreed the network verified transaction. That means what you call it as consensus. So on the left hand side, it's a shared ledger. That means like only once you can append the record. Second, it's all parties are verified with the network transaction. That's called consensus. And it ensures secure, authenticated, and verifiable transaction plus cryptography, what we call as cryptography. Plus, all business terms are embedded in a transaction database and executed with transactions. So that means it's a shared contract. It is kind of a legal contract or what we call it as smart contract. So, what is blockchain in a nutshell? It's a combination of shared network and shared ledger plus shared contract, which works through consensus and embedded in a cryptographic way. And why it is important? Because it has broader cost participation, lower cost, and increased efficiency. So the core function of blockchain is as a historical record which cannot be modified after it's created and is difficult to tamper. That we have been telling about this. And it's a means of making and settling transaction without the need for central authority. So if someone asks what are the core function, that means like a historical record cannot be modified once it's created and it's difficult to tamper. And second, as a means of making and settling transaction without the need for central authority. So the key attributes of blockchain, let's see what it is. So some of the magazines produce it as a trust mission. Economists that said that the promise of blockchain and the blockchain lets a lot of people who have no confidence in each other collaborate without a neutral central authority. Simply put, it's a mission for creating trust. Just a few thoughts from various papers, economists just like that. So let's start back where the origins of blockchain again back. Blockchain was created to enable Bitcoin. And the questions are Bitcoin or a scarce asset? Yeah, it is through digital mining. So Bitcoin is the first decentralized digital currency, as it doesn't rely on any central government authority. Some questions are like Bitcoins are scarce. Yeah, there are finite number of Bitcoins, that is 21 million actually available, but it may increase once the value gets increased. So yeah, real currency, it's a currency because it has a value and you can do all the transactions. And so what happens is as more and more digital currencies evolve, the banking financial world will do changes in such a way that it will revolve around the forefront of blockchain evaluation. So we did see this case. Person here wants to do a money transaction. He goes to the money exchanger, asks for a Bitcoin, and Bitcoin he buys products and goods, and again person B takes the seller takes the money to the money exchanger and bank, and he converts that into the fiat currency. So fiat currency or the normal currency that we use on a daily basis. So let's understand a bit of what is proof of work versus proof of stake. So this again, we just wanted to a member of the network wants to carry out a transaction. Once the transaction is generated to the whole network, and individual members of the network called miners check whether the transaction takes place. This we have detailed in earlier slide also. And fourth, once the block has been verified in the network, it is the own copy of the blockchain. And whoever is successful can easily verify the block is indeed sound. If the transaction is valid, it produces a block containing the transaction. So it's a very 6-step process and it's very robust. Here is the end of the session. Next, we will learn some important business rules and also transaction processing rules in blockchain. Thank you. Blockchain business rules and definitions. Welcome to this session of business rules and transaction processing rules in blockchain. As we said before, for this, let's start with the consensus. So let's understand how consensus actually happens in the chain. That means like there is a party in the chain who wants to do a transaction, and he approaches the network for a ledger. Like means he goes to the exchange and he probably buys a Bitcoin and then he wants to transact. So what happens is, so you should at least have a secondary main chain actually at least should have 51% computing power. That means the people who are in the chain should approve at least 51% consensus. That means like people of 51% should agree in the chain that whether in the blockchain for the transaction is that they have to check whether the transaction is valid. So that means like the consensus happens only when there is a approval. It's not an approval, there is an agreement within the chain that it has to be a valid transaction. It has to get approved by at least 51% of the people who are having nodes or who own the nodes in the transaction. So that's kind of consensus. So for anybody who asks you, you should have at least 51% approval or acceptance within the blockchain to do a consensus. So that's basically the consensus. So again, go back to the thing. What is blockchain? A blockchain is a distributed ledger that contains financial or non-financial transactions, is replicated across a number of systems in a real-time or peer-to-peer network. Every participant owns the same copy of the ledger and they get the same transaction is added. Every participant helps to determine the intrinsic immutability of all existing records. Understand this, very, very important. Immutable means it is a trust that is created. It cannot be reversed. It is immutable. Once done, it's done. Then it uses cryptography and digital identity signatures to prove identity, authenticity, and it enforces read and write access rights. And it has mechanisms to make it hard to change historical records, or at least make it easy to detect when someone is trying to change it. So every person owns the same copy and it's immutable. That means once done, it's done. So contracts, transactions, and record keeping in the digital age. So we have seen that we have actually, when we were understanding what is accounting principles, we did understand what are contracts, what are transactions, and what are record keeping. For example, in the digital age, the pace of innovation has not only done technology-driven business administrations. All companies keep records of transactions, but they don't have master ledger. So in terms of it's very important because, for example, in a contract management or a security trading, there is a huge case that is kind of complex because the more and more documents are coming through. A lot of issues in terms of how they store the records. So, for example, if you use Amazon online, like whether can retailer cards be based on Bitcoin, or Skype, like whether you have a smart contract execution or private ledger for email network. So these are some of the complexity going forward with the digital age. So these are the ones that can be addressed through blockchain. So basically, you have aggregation of transactions and by different miners. So these two new blocks can be formed from one earlier block. This is called a fork. Each fork can grow at a different place and one will be longer than the other. It depends. The shorter fork will then cease to exist and all transactions will follow the longer fork. This is a self-correcting feature as a part of governance, and this is based on the Byzantine general problem. So that means like no one can supersede the majority unless he has exceptionally computing power. That means your computing power has to be very high. And these miners typically there are a lot of mining facilities across globe that's getting popular. So it's very simple. There are different miners. There can be two new blocks, and each time a block is formed, it comes from a fork, and each fork can grow into a major place. And the person with having large computing power can actually supersede with the short fork. It's as per the written in the as of the to just make sure that it is part of a governance. So there are three types of blockchain. Please understand: public blockchain, private blockchain, and federated consortium blockchain. So I have given certain what's the difference between all three. That means access public blockchain anyone can do. Private blockchain is kind of single organization, and the federated is basically you have conglomerate or the consortium of organizations. Participants, it's permissionless. You can do it anyway. No, you don't have permission. Anonymous. Private blockchain, you know who are the identities and its permission. Same thing with federated. Security, here you have consensus mechanism. We did see what is proof of work and proof of stake. I'll go in details about this again. Whereas private blockchain, it's a pre-approved participants and it's based on multi-party consensus. Same thing with federated consortium blockchain, and transaction speed is much slower in public blockchain. It's a bit faster and lighter in private and consortium. So essentially, you need to understand that security and transaction is the most key, and in public blockchain it is permissionless, whereas in private and federated it's permission, and it's who are the identities who are doing the transactions. So again, I'm just giving through. Blockchain is a public ledger of different of the Bitcoin transaction that have been ever executed. This is one of the old stuff. But altogether, a blockchain is a type of database that takes large number of records and puts them into a block. So this is actually defined by UK government for science. And blockchain is a sequence of electronic files in which an entity-linked transaction of data is gathered and condensed. So it's kind of from Takashi. And some Deloitte, extended that a blockchain is a technology that allows people who don't know each other to trust shared value of events. This shared record or a ledger is distributed to all participants in the network who use the computers to validate transaction, and this remove the need for a third party to intermediate. So the various kinds of definitions as per blockchain. So 5 basic principles we need to understand. First, it is a distributed database. Each party on a blockchain has access to the entire database and its complete history. No single party controls the data of the information. As I told earlier, every party can actually verify the records of its transaction partners directly without an intermediary. Second, it's peer-to-peer communication. There is no approval mechanism. Communication occurs between peer-to-peer instead of through a central node. Each node stores and forwards all information to other nodes. It's transparent with pseudo-anonymity. That means every transaction and its associated value are visible to anyone within the system. Each node are used as a 30+ character alphanumeric address that identifies it. Users can choose to remain anonymous or provide proof of identity to others. Transactions occur between blockchain addresses. So transaction is very transparent. It's just a single line of code, which is software code, which has 30+ alphanumeric characters. So first one was distributed database, second one was peer-to-peer transmission, third is transparency with pseudonymity. Immutability is seen irreversibility of records. That means once a transaction is recorded in the distributed ledger, records are essentially impossible to alter because they are linked to every transaction record, and that comes before various computational algorithms and approaches are deployed, and to ensure that the recording of database is permanent, chronologically ordered, and available to all the network. So once you create a record, it's impossible to alter. Your lot of computational algorithm that was applied to ensure that the recording of the database is not at all tampered, it's permanent, it's chronologically ordered. That's very important, and it's available for anyone in the network to add. And computational logic, this is the important one. The digital nature of the ledger means that blockchain transactions can be tied to a computational logic and in essence programmed. So you can also come with more and more algorithms that actually make sure that the trigger happens at a transaction between nodes much faster. So anyone can write computational logic which can actually help develop more faster transaction processing inside the blockchain. So these are the 5 basic blockchain principles which we need to identify. The first one, I'm again telling, distributed database, peer-to-peer transmission, transparency with pseudonymity, irreversibility of records, or what we call it as immutability. Please understand what is immutability, and finally computational logic. So with that, we complete the fundamentals of blockchain and how it fits the distributed ledger in this part 3 of the chapter. So that's all for this session. In the next session, we will cover transaction processing rules in blockchain. Thank you. Transaction processing rules in blockchain. Hello, in this session, we will cover transaction processing rules in blockchain. It is going to be very interesting, so let's start with this session. So let's continue. We have understood what is blockchain. Let's understand how transaction processing happens in public and private blockchain. We did understand what are the differences, and one of the things is private blockchains are a bit faster, but public blockchain takes a little more time. So let's understand in this section. So what is public blockchain? It is permissionless distributed ledger. It's no central control is there. Participation is open to the public. Anyone can read, write data. Verification process is open to all. Security and trust is through knowledge distribution, and it's a technology-based security. Knowledge of identity not needed. Transactions are publicly available, lower cost, slower transaction speed, and platform code is open source. That's important. So anyone can take the code, and it's open source, so they can actually develop using any of the functionalities in public blockchain. Private blockchain, we call it as permission distributed ledger. It is subject to some central governance or control. selected group of participants, for example, within an industry or enterprise. That means, like, for example, if you have a, say, logistics industry, and then the companies which are in logistics industry can actually form an enterprise or a consortium to have a blockchain. And security due to verification, identification of controls. It's basically a technology-based security. Transactions is not public. It's kind of high running cost, but it has faster transaction speed. Foremost thing is platform may be proprietary. So why blockchain? Because blockchains are emerging technology patterns that can actually radically improve banking, supply chain, other transaction networks, giving them new opportunities for innovation and growth while reducing cost of risk. So in the right side, you see, right, you have transaction numbers on block 17, you have transaction numbers on block 18, and transaction numbers on block 19. So it is a secure and trusted record keeping. We saw that it's a immutable of transactions, contracts, or other legal tender or documents. By design, nobody can modify, delete, or even append to the record. So that's a significant aspect of blockchain, and it only happens through consensus. That's very, very important. So it reduces complexity and cost. For example, if you want to have a demat assets, like for example in the current share market, so its current system is like, you have a centralized depository. Most participants are disconnected from their asset depository. That means, like, settling a transaction would require participants to collaborate in a flow that is slow, inefficient, and expensive. That means the participants keep doing it and it finally accepts it. But it requires a lot of approvals, and it involves third parties and potentially trade operations. It is complex. It takes a little more time. Maybe T+2 is the settlement time for any participant to get the money back into the account. So it's a little inefficient and inexpensive. But with blockchain, it just offers a direct way. Everybody is in the same ledger, and the depository is on the shared ledger, whether you are a custodian bank or a clearing parties or trade depository or trading platform or a customer. So all, if you see the bottom down, it completely changes. They are all in same ledger. So when they are having a shared repository, all participants can interact with depository directly without involving third parties, and potentially making use of trade operations much cheaper and faster. So that's how blockchain is actually very important. So again, we have seen this. Suppose I as a person wants to send item X to petty B. The item could be cryptocurrency, contracts, or any records. So what happens is, Alan posts a record. It goes into the hashing character, and the encrypted transaction is sent out to all nodes in the network. And once it is, then you have a verification. There's a decrypting of the message with Alan's public key to ensure that transaction was sent only by Alan. And then they will trace back the chain of ownership, what is it, and whether it is unspent. That means, like, whether it's unutilized, it's a new transaction. And once the transaction is a valid transaction, it is written into the ledger. So verification is performed by a difficult computational problem based on the value of the block. So once a node verifies a block, the confirmation is published to all the nodes of the network, and block gets added to the chain, and transaction is accepted and complete. So it's like a typical 3-6 workflow, which is like having around 3 to 4 steps to make sure that the block is complete once the validation is done inside the transaction processing, inside the chain, or inside the network. So this is another type. This is how it is. Once you have a blockchain transaction, each node verifies the transaction. So that's what you see, 1, 2, 3. So that 4B02Y is actually each node verifies the transaction. Be it one first node, second node, third node, or a complexity of fourth node, fifth node, it keeps going. So that one single transaction is actually verified for the Bitcoin dollar transaction in the blockchain. So once it is verified, a new block header comes, and it attaches to the hash of previous block header. So that's how the transaction happens. First, it is verified. This section is about how verifications are done, like how transactions are accepted. So earlier the transaction was 6Z8ET and Y75R5F, if you can see in the block. And you have a block header, and then you create a new block header where this transaction can go and sit either in the old one, or it can also create a new header. That means, like, multiple transactions are batched into a block. And this block is distributed into the nodes. Understand this? It's a kind of a computational contest. It's a kind of programmable code which keeps attaching itself to on a regular basis so that a transaction is valid, and it matches itself automatically to make sure that it forms a block. So that's a simple thing how transaction is processed. So you have applications, banking, finance, and capital markets. You can see some of them. JP Morgan is choosing a building in blockchain on Ethereum. The other companies, Visa is trying to use blockchain for cross-border payments. These are some of the snippets from various kind of net search. And Wall Street is also looking at blockchain investments up to $1 billion. So these are the companies which is kind of going in Gangu with the, be it Santander, be it Thomson Reuters, which is a research company, to Toyota, to UBS, all of them are experimenting blockchain. The most important thing is its blockchain has a lot of corporate governance. So in one of the distributed ledger share clause in the Corporation Law Council, it has been given a strong backing to this initiative because it's a legal code and it's very important. So corporate governance is definitely managed well with this blockchain. So another use case is corporate governance and EOT. For example, if there is a large company and you don't have to send physical records or by post or by courier, all that you need to know is having a blockchain, and the government, the stakeholders or shareholders can just vote it. Another one, Nasdaq is using to blockchain to record shareholders' votes. So that's again what we call it as e-governance or corporate governance or EOT. Ubiquity is used for blockchain for real estate transactions. It's used for supply chain. That means like people have started looking procurement and supply chain using blockchain. It's also tracking academic credentials on Bitcoin blockchain. It's also looking landmark transactions, including global trade using blockchain. It's getting used in healthcare. So I'm giving snippets how blockchain is actually applicable across industries, across companies. HealthIT.gov is using kind of blockchain, and you kind of have blockchain as a service. This is offered by IBM, Amazon, Azure from Microsoft. So basically, it's an enterprise offerings for developers that integrates blockchain-based apps run on the cloud. So customers can create private or coalition-based blockchains and add software tools, speeds development. And IBM plans to combine Watson IoT platform with blockchain apps and also to have smart contracts as a part of the app. These are some of the current ones. And you have Ethereum blockchain as a service. People are using it for ticketing, payments, loyalty programs. So CloudChain is a classic example where you get ticketing platform. And loyalty programs are increasing because any retail company, they want to have a loyalty program, they can keep using blockchain. So even physical world, like, IP related, everybody is using blockchain. So again, it is used for fraud, starting with diamonds. So even in the precious industry or the mineral industry, it's kind of used. Everledger is a very good platform. Even for content licensing and distribution, digital records management. You have songs, you have your own videos. It can be patent, it can be kind of authored and validated using blockchain platforms. And that means like you have a decentralized content distribution, like be it like Netflix or any of the content, it's already available, which is a future of blockchain, decentralized content. And even it is used in gaming, where you can actually have a professional platform for traditional football players. This is one of the ones. Private equity, you see like companies like Deloitte and other private equity players using blockchain to invest. Other applications can be in higher education, public sector, energy, even in postal services and all other gift cards. So it is numeric. So till that we have seen what is a transaction processing and typical applications in the various of blockchain in various industries and some of the use cases till now. Hope you have understood till now. In the next session, we'll get an idea about blockchain technology stack and its different layers. Thank you. We'll talk about blockchain technology stack. Welcome to this session. In this session, we'll be covering blockchain technology stack. So we have seen about distributed ledger technology, and also we understood blockchain in the earlier modules. In this section, we will be understanding the blockchain technology stack to a little more detail. So we had legacy eras, that is like data computation, data applications, transaction processing, business intelligence. That's all before 1994, and then we had internet years. That's like e-commerce, self-publishing, personal communications, and now we see blockchain promise, basically decentralization of trust, enabling value without intermediaries. So we did discuss that, it produces single trail of trust, and you have immutability, and it's secure in better than the yesteryear technology applications. So blockchain is the new generation enabled by decentralization. So what is blockchain? We have already read through. Blockchain is an established technology, based on established technology, but it's integrating into a robust solution that actually eliminates the reliance on trust, but specifically assigns trust to the community at large having the blockchain. The established technologies are, so what happens is blockchain is a combination of many of the technologies. So it's a distributed database. That means it is having a database of blocks of transactions that are timestamped. So we did see how the blocks get developed. Then it is cryptographic tokens. That means it's public key infrastructure, which is having both public and private keys. PKIs are one of the popular cryptographic methods, which many of us may be aware. Then it is managed by cryptographic hash algorithms. Like it's like a signature for a text string or a data file, and it's based on peer-to-peer architecture. That means like every node is a client and a server. It's also happening through consensus, because whatever happens, basically collectively it is endorsed within the chain. And it's a programming language. You can ability to program if then else like kind of statements. So if you really look at it, blockchain is a combination of at least 6 to 7 existing mechanisms in terms of having a robust solution. So that is the technology stack. So again, we are reiterating in a detailed way how blockchain works. For example, someone has requested a transaction. So this second part, you see the requested transaction is to broadcast to a peer-to-peer network, or what we call P2P network. We can say P2P in pink, consisting of computers known as nodes. So it goes as a P2P network consisting of nodes. Then in the nodes, what happens? Network of nodes, it validates the transaction and the user status using algorithms. So it will understand whether the correct transaction is valid, and then it gives you the verified transaction. If a verified transaction can involve cryptocurrency, or it can be contracts, records, or other information. So there are two parts. Once after the verification is done, it combines with the other transaction to create a new block or a new block of data for the ledger. The new block is then added to the existing blockchain. It is permanent and unalterable, and the transaction is complete. So you understood, right? The verified transaction can involve contracts, records, or any other information. It can be cryptocurrency. So once the transaction is verified, it combines with other transaction to form a new block or of data on the ledger, and the new block is then added to the existing blockchain, and it is non-permanent and unalterable, and the transaction is complete. So understand, if the blockchain, if the verified transaction is a cryptocurrency, then if it's having intrinsic value, then no intrinsic, then it's not redeemable. It's physical form and it exists in the network. If its supply is determined by central bank and the network is completely decentralized. So that's how the entire blockchain works. Blockchain technology can simplify modern banking, because you have seen in some of the snippets earlier that many of the banks like JP Morgan and Santander are all investing in blockchain technology. So what is like a new process? This is a distributed consensus. Earlier in the left hand side, you see a centralized database and it has a centralized ledger. Whereas in this process, it is a decentralized database, distributed ledger. So that is most important. So you have current systems. How is the banking happens? It's like central bank, and all banks are related to the central bank, and it's a centralized payment system. Whereas here, if you see public blockchain, it is permission. So you have large network of people where the transaction happens, they approve it within the ledger or the blockchain. So private blockchain is within the group, and you know who are the actors. So if you see the current difference with the existing architecture, just take the internal processing system or internal transaction system. The architecture is based on central database. The central settlement process is internal. The speed is real time, but transaction cost are relatively simple, but it has third-party system. Similarly, middleware or messaging, it again secure inter-party. It is independent, but then depends on the centralized processing, and it's an external processor. That means on the middleware and the messaging. And if you see the clearhouse, again it is a third-party agent in possession. Settlement process via clearinghouse, and its limitations are complex and cumbersome and expensive.
So when you take internal transaction system or middleware managed messaging or clearing houses, the current architectures in the terms of financial and banking system, this is the current system. But whereas blockchain, if you see on the extreme right, it is a distributed ledger with cryptographic integrity. Settlement process, it's a consensus. Speed near real time to minutes. Transaction cost similar to internal databases. Benefits, it enables third party transaction to be simple and efficient as an internal transaction. Issues, it is still maturing, but it can integrate with the existing systems and workflows. So essentially what we are telling is blockchain distributed ledgers provide efficiency of a central database and robustness of a third-party clearinghouse for complex distributed transaction without any costly middleware. So that is the biggest advantage, and your speed can be reduced from 3 to 5 days to just immediate. So blockchain runs on hash functions. We have seen that in the earlier slide. Like human fingerprints, hash function is a way to verify the fingerprint that matches a specific person, but without the ability to create the person from the fingerprint. So if you really understand, the technical design of a blockchain is evolved through a number of iterations by using hash functions. Basically, it's a mathematical operation which creates a digest of the transaction. For any input, you will have an equivalent output. That means it identifies the data and has the ability to recreate it. Thus, you can see in the figure, SHA-256 hash function is used. For example, if I give an example as Fox, it has a cryptographic hash function. The digest is DFCD3454 and so on and so forth. The same thing, if I do red fox jumps over the blue dog, then it is 008646BB, FB7D, CBE2803C, like that. The red fox jumps over the blue dog, the cryptographic hash function. Then again it goes 8F7DB and things like that. Then the red fox jumps over the blue dog. It has again unique function. And last one, if it is OEVR or OVER, each hash function is unique. So basically, every input produces a 256-bit hash, no matter what the size of the original data. That is the most crucial aspect of this. So one of the distributed ledger technology specialists, Mr. Richard Gendel Brown, actually he said the first and most important feature is what is genuinely new in terms of scale and scope. And is that they create a world where parties to be shared the same fact from the stakeholders. I know what you know and that I know what you know. A simple it's a kind of a scale, the process that he is talking about. So who is doing what? So this is one of the example where R3 Coda, it's a company where they are trying to build a ledger, an open source distributed ledger for financial services. It's kind of found by Peter Randall, and there are building loyalty points using EPAM, So that's the one which is kind of blockchain infrastructure for loyalty programs. Similarly, you have a future of financial structure, they understand how does it work and they looks at the full potential scope of the blockchain. He has written several white papers on how the blockchain ecosystem looks like. It's getting mature. So R3 Coda and some of the latest technologies in the enterprise blockchain. Then we have Hyperledger project. We will come through on each of these when I go through in third module. It's basically Hyperledger project is a community of software developers building blockchain frameworks and platforms. The key features are its architecture is based on smart contract based on called chain code. It is hosted on container technology. If you understand many of them, containers and Dockers are the most useful ones in cloud. And they are using that, and the development is basically open source. It's collaborative, cross industry, and hosted by Linux Foundation. So it's one of the unique ones. Hyperledger is created in order to encourage and facilitate cross industry platforms through an open source, compartmentalized, and collaborative blockchain platform. So that's the uniqueness of Hyperledger. We'll go deep dive into this next few modules. So in this one, we have seen what is Hyperledger and what is Corda.
So here is the end of the session. Next, we will know how we can actually architect a global scalable blockchain. Thank you. Hello, in this session we will deep dive into how to architect a global scalable blockchain.
You understand how blockchain happens, what are hash characters, what are the functionalities, and how cryptography works. Let's understand a bit of architecting a scalable blockchain. So if you take a Hyperledger fabric, you have a consensus fabric and you get chain code A, chain code B. It's kind of smart contracts. And once the consensus is happening within the chain, within the fabric, then the kind of blockchain is formed. So apart from that, there are many more blockchain initiatives starting from physical layer, data link layer, network layer, transport layer, across layers, all the 7 layers of the communication, you are seeing investments. Like for example, in the transport layer, Docker is used, and there's a P2B broadcast library. Then at the network layer, there is something called Gossip. Then data link, they are gRPC, and it's made of Angular or Node.js. And HTTP2 is basically blockchain tech lab. So
If you see across 7 layers, at least the top 1, 2, 3, 4 physical, data link, network layer, and transport layer, blockchain initiatives are actually getting created. And similarly, you have even in the sessions layer, that is PBFT, presentation layer, you have SDKs, application layer, you have Go Java. So basically, Hyperledger Fabric across it fits in So we are trying to compare most of the fabrics, most of the initiatives. Like there are many initiatives, Hyperledger Fabric. Now Hyperledger has taken over Sawtooth, it's Blockchain Explorer and Iroha, and there is a comparison between R3 Corda and digital assets. So you see top of them are all new initiatives, and you see how each layer actually they are investing into each layer. That means like from the physical layer to application layer, how each company is investing into this blockchain initiative. So again, we have been seeing this value of a blockchain. It is a decentralized processing network. It is based on distributed ledger. It has digital signatures. It has a programmable logic, and it complies of private and public. So it's a significant opportunity. Blockchain to link disparate system of parts of one enterprise together or many different organizations from within the same sector. So if you see the fabric comparison, just there is an attribute, there is Bitcoin, there is Ripple, there is Ethereum and Hyperledger. So the top fabric comparison is built in this. For example, we will see whether it's permissioned or permissionless. Bitcoin is permissionless, Ripple is permissioned, Ethereum is permissionless, and Hyperledger we discussed it's permissioned. That means a private blockchain. And you have a consensus algorithm. Bitcoin runs on proof of work. Ripple is again kind of custom made. Ethereum is again proof of work, proof of stake. And Hyperledger is basically open source. It's basically based on Byzantine consensus algorithm. And smart contracts in Bitcoin, it is stack-based scripting language. Ripple doesn't have any smart contracts, whereas in Ethereum you have Solidity, and in Hyperledger it's Golang. And if you see the cryptocurrency, yes, Bitcoin has BTC, Ripple has XRP, that is XRP Ripple coin, Ethereum has ETH, and actually Hyperledger doesn't have any cryptocurrency. And finally, Bitcoin doesn't have any encryption, whereas even Ripple doesn't have, and Ethereum has a smart level contract level confidentiality, but here fabric level confidentiality is there because it's a chain code in the Hyperledger. So exactly you have 4 to 5 attributes, and you can see the comparison of how Bitcoin versus Ripple versus Ethereum versus Hyperledger is kind of getting used in the market. So debt developments for future applications, you see a lot of applications. You have cryptocurrency, you have registry which is used in the land records, you have values ecosystem, you have value webs in the finance world. So basically everybody is using Ripple, R3, Factom, all these people are using, and even it's been tried by NASDAQ. So it can be opportunities, domestic and international payments, trade finance, and capital markets. So we have seen this cryptographic hash algorithm is used in Bitcoin blockchain, but SHA, as they popularly call it, secure hash algorithm, is one of a number of cryptographic hash functions. So basically a cryptographic hash is like a signature for a text data file. It's like a algorithm is used in Bitcoin, and it generates a 256-bit or a 32-byte hash. And hash is one way of function. It cannot be decrypted back. That means we have seen this example. The quick brown fox jumps over the lazy dog, and you see a hash function D7A8BB, which is on the right hand side, 07D7 809469CA 9ABC 0082EF4, so on and so forth. So if you understand the blockchain technology transaction layer, there are other blockchains from those Bitcoin systems. There are also variations in the way process to create blocks in other blockchains. Bitcoin's transaction layer only handles cryptocurrency transfer. But in other blockchains, it is used for identity, property titles, logistics, etc. We have seen that all other use cases. But if you see the common denominator with the blockchain solution is a blockchain provides inherent trust mechanism and immutability of data without intervention of trusted parties like bank. That means the common denominator is that it has a transaction layer. It runs on transparent inherent trust mechanism. It is immutable, and it doesn't have a centralized intervention of current trusted parties like banks. So this is the variation. It comes from the current industry applications. So you can see in this example how previous block with the height and header hash, they keep adding to that to form new block. It's just a representation, just for your information. So you can see like block depth and block height. One thing you have to understand is blocks are normally referenced from their block height number. In how many blocks from the first block created in 2009. At least in the sense of Bitcoin. And then block depth is the depth of block of interest from the latest block. That means at what depth it goes in each block. The deeper a particular block is from the latest block, the more difficult it is to alter the transaction of the block.
So you understood, right? One, blocks are normally referenced from the previous block height number. Block depth is the depth of block of interest which contains transaction from the latest block. And the deeper the particular block is from the latest block, it's very difficult to alter the transaction. This doesn't mean that the later blocks are easier to alter. This explains that it is much more difficult. So this makes only one statement, that immutable, or it cannot be modified after creation. That's what we have been telling. It is the more deeper or doesn't matter. It doesn't mean that blocks are easier to tamper. So it's very difficult, and that property, what we call it as block height and transaction immutability, is the most crucial in blockchain. So it depends on each transaction. After the transaction happens, it keeps attacking to the same block. You can see block 1, block 2, block 3, block 4, block 5. And the more successful mining you have, the adjacent node 1 becomes mining node, and adjacent 2 to adjacent 1, then adjacent 3 to adjacent 2. This is how it happens. Basically, it is verified and assembled as information on successfully mined block is passed to the adjacent nodes, and the other informal, unverifiable, non-compliant will not be passed to the adjacent nodes. So that is important. Which is verifiable, which is verified, it will move on to one adjacent node to another adjacent node. The one which is not compliant will not move to the adjacent nodes.
That's all for this session. We will understand the blockchain generations in the next session. Thank you. Hello, welcome to the session of blockchain generations. In this session, we will get an overview of the blockchain generations.
So we will understand how block generation and overview. Basically, you see Bitcoin transaction as example. It creates a selected transaction, and the transaction hash is passed down to kind of a Merkle tree. It's a hash rate which happens within the system that is existing within one block to another block. So if you just look at the double hash, how the system is calculated, it's a target computed by the system passed on by several parameters, suggest that every block can be mined approximately at every 10 minutes for the previous block to arrive at a solution. So that means like it's a kind of a Merkle tree, and nonce is just a kind of a number. And so before every 10 minutes you have a block that kinds of get assimilated between each block, and the hash rate of each block is different from one hash rate to other hash rate, and it kinds of gives you a proof of work, like in terms of how the whole this thing is anticipated. If the mining all characters is met, then it goes to node 1, node 2, node 3. So basically the output of the block is complete when the proof of work is complete. It's very easy to it's little transactional based, but then understand that a system calculates the block depending on the mining process and how much investment has gone into the compute power. And in terms of Bitcoin, this is around 10 minutes. So for every number of hash that's created with other inputs, it kind of get attached to the previous hash with a timestamp, and then it forms a block, and then the whole block is kind of given proof, and then it makes a node, and in each node you have different blocks. So basically, this is kind of Bitcoin on transaction block, but again, this is a very crude system that we have just put it here. We don't have to go through more technologically, but just understand that a Bitcoin-based transaction block gets mined up once in 10 minutes, and you have it's like a hash transaction which is based on Merkle tree, and there is a timestamp to that, and every accepted block with the adjacent nonce value given output gets attached to the previous block or the new block, and each block gets on to added to each node which is found adjacent. That's the only thing. That's a summary of this slide. So as I said, every Bitcoin or any other blockchain transaction has based on encryption. Basically, it's a transaction level security, and it's one way. We have seen hash functions, and it cannot be reversed. Each Bitcoin address is either a public key or a private key. That's the only essence of this slide. So we are trying to explain what is a block hash header target. The network is attempting to find a block whose header hash is less than this. So as you see, there are a lot of zeros at the beginning of that hash. The meaning that acceptable range of hashes is much smaller, hence it's more difficult to find a hash. It will take an average of more than 150 quadrillion hash calculation per second to the network to discover the next block. That seems like an impossible task, but fortunately the network is bringing 100 petahashes per second of processing power to bear, which will be able to find a block in next 10 minutes of an average. So just understand, so much of power is required to make sure that the next block is kind of created in next 10 minutes on an average. Let me explain how blocks linkages in a chain through proof of work. The proof of work is a computationally intensive process
called mining, and all mining nodes will race to generate the proof of work block after block. So understand, it's a computationally intensive process called mining, and all mining nodes will race to generate the proof of work block after block. After block is formed, resulting from successful proof of work, that means the communication is accepted to other nodes, it would become very difficult for earlier transaction to be altered. Hence, its security is very high. So what is proof of work? It's a computationally intensive process called mining, where you can generate mining nodes to generate blocks. And at least in Bitcoins, they are kind of rewarded with 12.5 Bitcoins and transaction, but this has come down very well now. So you see block 51 kind of proof of work done, then it goes on from more secure, like, block 52, block 53, block 52, block 51. It keeps going, and the more and more mining power happens, the more and more generation happens using proof of work. So there are other alternative proof of work is proof of stake and proof of importance in other blockchain. This is more towards Bitcoin. So summary of transaction immutable through blockchain. Each mining node verifies transaction using previous block header hash and timestamp before it starts mining. Mining nodes will mine concurrently to solve a mathematical problem. We have seen this. The node that first successfully mined creates a block which relays its block information, that is transaction, previous header, block header, timestamp, and mathematical called nonce, to the adjacent node. The adjacent node will verify that all the information provided by the successfully mined node is correct, or before creating a block and relaying the same information to the adjacent node. So very simple. Each mining node verifies transaction, and it solves a kind of mathematical puzzle. Once that is done, then it relays its information, that is transaction, previously blocked header hash, timestamp, and the mathematical solution called nonce to the adjacent node. The adjacent node will verify the information, and again it goes on and the process is completed. So in the event that if the same node is giving incorrect actions, the receiving node will reject, obviously. Thus, the immutability is assured through blockchain creation. That means like earlier blocks are linked and distributed blocks, databases in blocks in adjacent node. The best thing is that the system assures trust without relying on a single party. So at least in a strength, like there are over 6,000 nodes, that it is unlikely that immutable will be compromised. This is the core strength of the blockchain that caught attention of the many observers. So blockchain, what we call it as distributed ledger. So in the event, if there is a default issue, the adjacent node will not receive the information. So it will kind of create with adjacent nodes, and so again it is very difficult to tamper. That's why it is called as distributed ledger and immutability. So basically this is how the transaction happens in a Bitcoin. That means it goes from one person to another and one wallet to another, and miners generate millions of hashes. They get incremental nonce, and each nonce will create a new hash. So that's how the Bitcoin, just for a representative purpose, the hash must include a number called nonce. So basically there are 3 steps. To create a new block, miners must find a hash, meet specific requirements. Hash requirement should have a header of previous block. It should be less than the target number, and it should include a number called nonce. So this we have seen in the earlier slide also. So what is the security benefits of blockchain? A blockchain approach promises additional security needs. It standardizes data, and it has more data efficiency and data acquisition. It actually offers a path to transfer data ownership rights to individuals. It removes need of trust to a central utility, which that current one will not applicable. It protects data through immutable records. That is all seen on the right hand side. It is data protected through tokenization, because tokens are PKIs or the key identifiers. It's real-time processing capability. With all these complexities, it still process real-time. It has multi-sign authorization and capability, So that's the beauty of this entire process of blockchain, and that's how it's more secure. So let's understand what are the components. You have 3 components of a blockchain. You have a blockchain ledger, you have a blockchain distribution, and you have a blockchain consensus. So let's understand each one of them. What is blockchain ledger? A transaction ledger where each transaction is tied to the previous transaction by a cryptographic hash to the entire ledger every time there is a new transaction. Got it? So it's a transaction where each transaction is tied to all the previous transactions through a cryptographic hash, and each ledger procures and whenever there is a new transaction. What is blockchain distribution? A system where all participants is in the consensus model and have a complete copy of the distributed ledger. And distribution can be public, partial, or security roles. It can be even private. A system wherein all participants in the consensus model have a complete copy of the entire ledger. That's what is called as blockchain distribution.
and distribution can become public or partial with security roles. And blockchain consensus is a process used to with distributed ledger that ensures all parties can agree on the validity of transaction and on the entire ledger. And what is blockchain? The fourth component can be considered as smart contracts, which is a process used to with distributed ledger that ensures all parties can agree on the validity of transaction and on the entire ledger. And what is blockchain? The fourth component can be considered as smart contracts, which we will go deep dive in the next few modules.
Hope you understand and get an overall idea about the blockchain generations in the next session. We will know what is smart contracts, traditional contracts versus smart contracts, etc. Thank you. Welcome to this session. As discussed, in this session we will discuss about smart contracts, traditional contracts versus smart contracts, introduction about the fundamentals of smart contracts. So let's jump to this topic.
So what is smart contract? We are seeing traditional versus smart contract. It is between two parties. Its execution is faster. Whereas in traditional contract, you have third party and execution is problematic. So smart contracts happens in minutes. Traditional contracts is, let me define what is smart contract. It's a single line of legal software code. And in smart contracts, you have automatic remittance, and in manual contracts, it is manual remittance. Here, escrow is not required. In traditional contract, you have need a escrow. It's a fraction of the cost, very expensive. It's virtually present. It's physically present. Lawyers may not be necessary, and law is necessary. That doesn't mean that smart contracts will get away with the lawyers, but then it is to be a new generation smart contracts where the execution is faster and it's more trustable and transparent, and actually it is immutable. So smart contracts, what does it define? It is not actually contracts. It's application based on the blockchain protocol which executes, verifies, and enforces the performance of a contract. So it's an ability not to store what has happened in the past, but also impact what happens in the future. It's actually intended to have paperless transactions with exchanges, cross borders in a secure way. Understand that it's a paperless transaction with strangers across borders in a secure way. What are the advantages? So it's not a contract, it's basically application based on blockchain protocol. It executes, verifies, and enforces the performance of the contract. So advantages being it's automated. No central authority is required for record keeping. Fully automated and self-enforcing, which is ideal for escrow and other conditional payment arrangements. No counterparty risk, and it has uses of oracles. Basically, it has web services where you can trigger information through contract enforcement. Example, price of commodities, transfer of money, legal filings, quotes, scores, etc., etc. So to summarize, it's not an actual contract, it's an application-based protocol for performing a contract. It facilitates paperless transaction for cross borders in a secure way. It is automated, it is fully self-enforcing, and use oracles to trigger contract enforcement. That's smart contract. So it's ideal for automatic transaction underlying the infrastructure of financial transaction and transaction within few continuances. So understand, you have a lot of issues in the financial transaction. So this is very ideal for financial transaction automation. It's well suited for escrow and conditional payment that we have already seen. So parties to smart contracts will be using code, that is software code, to develop the contract as agreed by the parties. So can lawyers become coders? Yes, maybe in future, or already it is started. So I'm just giving some of the examples where smart contracts are applicable. Use case, simple to complex. Digital value exchange, where kind of Bitcoin, that's a contract between coins. Smart right, basically consumer buys an item online, you get a right. Basic smart contract, a seller gives you a motorcycle and then he gives access to the smart motorcycle lock. That's kind of smart contract. Then multi-party smart contract, that seller lends buyer from funds to buy a car. It can be a corporation taking care of sales and exhibitions via shared ledger. A shipping company having multiple contract arrangements with a lot of consumers. Then a government is basically like all the public distribution and stuff like that. And it's also autonomous society. So you have various case examples that moves from simple to complex on a smart contracts. Now what is smart contracts? Lawyers will need to be like more programmers when they draft legal agreements. They should articulate the logic that will govern the relationship between two or more people in a way that the contract can be translated to a code. So it is going to simplify the legal drafting, more deterministic on a software base using the contract. So lawyers may need to collaborate with software engineers, and technology will work neatly because you have standardized templates or the forms with agreed terms, and potentially you have an issue automatically performed which is like legally modified, revoked, and it completely removes the fraudulency in the aspect. So if there is one party which is trying to dominate with the other one, you can completely reuse smart contract to get away with that. So there's a question, will lawyers become
programmers? Yes, maybe, but yeah, we have to wait and watch. So what happens is, if you see current paper-based systems, it drives $18 trillion in transaction per year. And consensus protocols is important. So for that, smart contract code, this enables peer-to-peer trading of everything from renewable energy to automated hotel room bookings. So everything can be contracted through smart contracts. That's a potential also. You are replacing a 18 trillion transaction market, starting from renewable energy to automated hotel room bookings. So let's understand what is Hyperledger. Hyperledger is an open source effort to create cross-industry blockchain technologies. It is a global collaboration hosted by the Linux Foundation, including the leaders in banking, IT, IoT, supply chain, manufacturing, and technology. It's a business blockchain frameworks are hosted with Hyperledger. The Hyperledger addresses some important features for a distributed ledger. So it is a collaborative project under the foundation. It is collaborated with Linux Foundation, including leaders in finance, banking, and you can visit hyperledger.org. Basically, it's a framework which is cross-industry, cross-functional, and being supported by many leading organizations. So you have a lot of Hyperledger projects: Hyperledger Burrow, Hyperledger Fabric, Hyperledger Iroha, and Hyperledger Sawtooth. So what is Hyperledger Burrow? It's a permissible smart contract machine with a blockchain client built into the specification of Ethereum virtual machine. So understand that it's based on Ethereum virtual machine. So there's a smart contract embedded with the contract. Hyperledger Fabric, it is a foundation for developing plug-and-play solutions with modular architecture. So if you want to build any decentralized apps, this will be the best fit. Hyperledger Fabric. Hyperledger Iroha is a blockchain framework designed to incorporate infrastructure projects like your cloud and other infrastructure. Hyperledger Sawtooth is a modular platform for building, running, deploying distributed ledgers. So you have each one of them: Hyperledger Burrow, Hyperledger Fabric, Hyperledger Iroha, and Hyperledger Sawtooth. Each one was an independent project. And when the Hyperledger became matured, all of them got into one, which is called a Hyperledger. Each one has its unique use case. So we have been talking about what is Ethereum. Let me explain what is Ethereum. Ethereum is a decentralized platform that runs smart contracts, applications that are exactly programmed without any possibility of downtime, censorship, fraud, or third-party interference. So Ethereum was actually bootstrapped in August 2014. And it's developed by a foundation called Ethereum Foundation, a Swiss non-profit with contributions from individuals and organizations. So Ethereum is a decentralized platform which runs smart contracts, applications that run like a program language. It uses Solidity, and you also have a cryptocurrency called Ethereum, Ether. So what is Ether? Ether is a crypto fuel for the Ethereum network. So it's basically a necessary element. It's a form of payment made by the clients to the platform, to the machines, executed for operations functioning so that developers can write quality applications. So the Ether supply is dependent by the donation that comes through the usage of Ethereum. Developers can intend building apps using Ethereum blockchain. Users who want to access the interactive smart contracts can also do. So basically, Ether is a crypto fuel that brings in funds to the Ethereum platform, and the developers can build apps for using it that can use Ethereum blockchain. And if they want to use smart contracts, again, it's open source, so Ethereum blockchain can be used for smart contracts. So with that, we kind of complete some of the Hyperledger transaction processing, how it happens, and Ethereum to a certain extent in this module. Hope we have understood whatever we have covered so far. Now it's also imperative to understand what are the key challenges to blockchain technology. Let's discuss about in the next session. Thank you. Hello, let's discuss about the key challenges of blockchain technology. So we have listened to a lot of concepts in blockchain, distributed ledger technology, and how transaction processing happens in earlier chapters. Now we will be covering a bit of why challenges to blockchain in terms of, there is widespread adoption, but it's not still a kind of full-fledged solution. So let's understand few of the blockchain, but innovations are coming across to make sure that the blockchain is going to improvise in the next probably few months or so, and it will be kind of widespread after, as you saw in the Gartner hype cycle, next 5 to 10 years. So first of all, challenges like legal, sometimes of clearance in terms of legal. So you have some kind of existing laws and see how it can be
apply to blockchain developments, but many foreign regulators across globe are kind of evaluating this. For example, Department of Treasury, US Commodity Futures Trading Company, then the International and Exchange Commission (SEC). So many of them are looking to see how they can actually use blockchain for their current addressing the problems and giving a solution to deployments. So the legal issues are there, but then they are getting to sort it out. The regulatory environment, regulators are focusing more on how they can actually make sure that currently how blockchain can be implemented. For example, in a recent thing SEC met and see how they can actually use futures and how they can make cryptocurrencies as a part of how they can want to regulate cryptocurrencies. They're also looking at how they can use exchange traded funds using cryptocurrencies. There's some of the discussions going on. So these are some of the examples. For example, NYS New York BitLicense they finalized in June 2015. It's the first agency to release a comprehensive framework for digital currency to know your customer. And basically, there are a lot of issues still, but they just issued a kind of a money transmitter license. It was treated like a money transmitter license, what they call it as a bit license. And basically, the keystone is the main aim is to protect consumers, so anti-money laundering and know your customer, and in terms of borderings, without shifting the innovation or the benefits. So this was one example. Then FinCEN started one of the CFR, code for regulations like money service business. It's called 31 CFR 1010.100FF. So this does not differentiate between real currencies and virtual currencies, and exchanges and payment processor are considered to be money transmitter unless a limitation or exemption applies. So this is one of the FinCEN in one of the this regulatory. Then you also had CFTC environment that was in May 2016. Again Hong Kong Bitfinex. So they was fined, and they're basically, this is just for information. So I'm just covering through some of the regulatory environment that has gone through in last couple of years over cryptocurrencies, blockchain, and and virtual currencies or digital currencies. Then IRS guideline in March 2014. March 2016, there was a California bankruptcy court under fraudulent transfer. So they said that IRS virtual currency guidance, virtual currency is treated as a property for US federal tax and general rules for property transactions. So they proposed it like virtual currencies are like what you call as property, and whatever tax liabilities are available for tax for property, this will be also equally available. So from Bitcoin to blockchain, we have a lot of regulations, a lot of consensus, but the thing is, FinCEN found that rule in FIN 2015 R001 in response to a company that provides internet brokerage service between buyers and sellers of precious metal. So they kind of used Bitcoin blockchain, and they were telling whether trading can be done or not. So they just give the answer. So basically, this falls under the money transmitter. So they gave the same reasoning, and any service under assets and digital will be subsequently freely traded. So that is the finding. So this is one of the use cases, the example that was there in 2015. So similarly, what are the challenges to blockchain in terms of smart contracts? First of all, it's a real world verification. So is there any that, how do you find the property may have to verify it under existing laws or certifications or third party authorities still be needed? Second is proof of identity. How to prove an identity is a trustless network? How will one link blockchain address to satisfy know your customer and related obligation? Those are one of the good questions. Many banks conglomerate or getting into conglomeration see if they can have one ledger where all the banks can verify the customer. Then taxation and bankruptcy, digital currency is treated as a property, and how tangible are there for blockchain assets under the tax or bankruptcy law? That is still a $100 million question. Jurisdiction is a centralized arena where transactions are running on international computer network without a central place. So how, in case of some deviation, fraud, which jurisdiction they go? Force majeure, what is unforceable seen in the blockchain world? Real relationship to real contract, how to address issues within agreement to which smart contract it relates. There are a lot of input transactions also, or input control, and then deviation, fraud, and or coding errors, how to address. So basically, there is a blockchain and law working group which is kind of getting these answers, and so that customers can be really coming out of the pain. So still compliance with UCC contract issues, how will blockchain mesh with existing UCC definitions? So they have given some under Article 9 of the UCC. Basically, it's a general intangible, means any property including things in action, forms of chattel paper, commercial dog, deposit accounts, and everything can be considered. Or investment property means a security, whether certified or uncertified, security instrument, security account. So this is the kind of challenges with smart contracts as well. Or should it be treated as a financial asset? So they've given some, what do you mean by financial asset? So there is a definition. or can blockchain be treated under financial assets? So these are some of the costs, again under article of UCC. So the other one is seen some legal challenges. How can we define, under what criteria can we define whether it's legally permitted? Do I have an obligation? Where to go in terms of fraud? All these questions are there. Next question is, how do you do the challenges, in terms of security? You have heard, a lot of hacks happen from the exchanges. Some of the high stake cut down happens in blockchain. Like a lot of exchanges got hacked recently. So many customers data got hacked. So what do you do there? That's one of the biggest challenge. So there was a big thing, in 2016. DAO was a crowdfunded investment firm, and what happened is the hackers found a software bug that allowed an investor to cash out shares repeatedly before system determined the user's account was zero. That means he was trying to take the money before the investment becomes zero. So that's a kind of bug. And that's how they utilized and hacking completely hacked. This is in June 2016. So what are the challenges? What are the applicable laws? So you have a deep dive of a lot of laws actually. So which jurisdiction laws apply? It can be under taxation. It can be under privacy and data security. It can be cross-border transfer. It can be how to determine whether any breach occurred or not. You need to balance confidentiality, traceability, and cybersecurity. And is there any conflict of laws consideration? So how will changes law be addressed in blockchain architecture? How would court orders be enforced and implemented against whom? So they kind of have what they call it as legal status of decentralized autonomous organization, or DAOs. Some questions need to be answered, and in the similar way, you need to understand the potential use of this blockchain. So we need to have a weighing average of how you can use the blockchain versus how laws can be applicable. So there are other issues like collaboration issues. In terms of, if 2-3 people are holding, distributed ledger, for example, Ethereum Enterprise Alliance, R3, which is Corda, digital asset holding. So how the collaboration will happen, whether ability of blockchain to be used to collusion or exchange sensitive information, or do they have the technical standards, or they are a potential dominance of few or blockchain providers, or is it a closed access granting of refusal to private blockchain, but then who are the gatekeepers in this? So you have various questions, and we need to answer this. Consortia. You have famous consortia Hyperledger, but we will have to see how we can outline the steps. Then you have intellectual property rights, as and when everywhere. Infringing materials on blockchain. Who would be responsible for infringement? Then is something like, if some service provider broadcasts blockchain wrongly, those things. And could takedown request be compiled with, and what are the applicable laws to blockchain providers, so on and so forth. The reason to highlight both is as a financial professional, you should be able to articulate what are the challenges and how you can address the business challenges for the blockchain in case you are going for a use case in say for a bank or for an insurance company or for a tokens or a wallet. You need to be understanding what are the legal issues, security issues, intellectual issues, and so that you have a proper usage of blockchain. So wave of patent filings, you see a lot of in last 1 year. If you see USPTO, the wave of patent filings have gone up, starting from JP Morgan to NASDAQ to SEC to Hong Kong, Shanghai Bank to Santander. Everybody is filing patents on blockchain, and the highest in terms of software development is coming from, I think, from IBM. So you see on the right hand side, Bank of America, Goldman Sachs, JP Morgan, Citibank, Bank of New York, so they're all submitting patents using open source or the blockchain that is kind of getting developed. So mainly as an intellectual property, efforts to own blockchain will necessarily focus on improvements in the technology. Underlying principle is that whether it should be with better encryption and it should be applicable to any kind of application, or it should have innovative ways of particular purpose or fields. For example, if it's like a banking field, it has to be. And can we call it as a patent pooling in terms of, if you have common thread between the blockchain, can we do a patent pooling? How we can structure it? These are some of the questions in terms of intellectual property issues. But there was a court case in terms of Alice Crop versus CLS Bank. Is distributed ledger an abstract concept that is not patentable? So there was some question, and there was a case, and the analysis was done by the lab as it was still unsettled and inconsistently applied. So this was one patent issue. There was another filing on October 31st, 2008. And revealed that there are 879 filings mention Bitcoin, blockchain, or distributed ledger. So this is how the list is: the blockchain patent rush. 824 mentioned Bitcoin, 159 mentioned blockchain, 55 mentioned distributed ledger. These filings have resulted in 150 issued patents and 729 published patent applications. And there are some 488 unique fillers. So this is some of the filings till February 16, and from February 2017.
Of course, I have not updated the data, but I have seen a lot of files, more than 1,000 patents have come, I guess. So other one is it's also open source. Some open source have patent grants and some realization process, so we need to be very careful of that. So certain conditions, we need to be having auditing on what is for compliance and how you can know your customer, how to address the fraudulent activities and errors, how to manage the tax and bankruptcy, who is liable for blockchain failures, what is dispute resolution in terms of a patent clash, or post-merger, what happens if something like completely down, or it also performance management of performance versus service levels. So these are some of the alerts that we need to be having, and we should be able to plan. And keeping away with all this, blockchain is still a very good technology, and it's going to rule the future, no doubt about it. But then we have to be aware of certain facts and figures. So we saw about the challenges, but then you can see every sector almost like in the way of blockchain implementation. Whether it's consumer products, manufacturing, technology, media, telecommunication, healthcare, license, it doesn't matter. Everybody is indicating. There was a survey, and they said like 39% of senior executives, large US companies, said that they are kind of deemed crucial for the companies, and 42 believe is that it will disturb the industry. So cross-industry adoption, cross-industry IT frameworks, open source, and there are so many things that we can discuss actually. Financial industry, definitely noted. We have been seeing some of the financial industries saw opportunities in blockchain, and they've been heavily investing in usage primarily as a part of private implementations. And the second use case is identity management, because as one of the issue is like how do you manage the physical asset versus identity? How do you map the identity? So we have to have corresponding entities to identities, identities to attributes. So that's where the diagram is showing. So basically, you should have identity management concerns, protecting the access of data, where to store the data, with GDPR in place, how do you store the data, report the data, what is ongoing resource dedication. And of course, there are multiple solutions available, but we need to be figure out the fact that identity management is an area that will be certainly impacted by widespread use of private keys to secure transactions. So you need to have audits at a certain place, and you should also have strong identity management attributes inside the blockchain. And it's also creating a lot of waves in distributed access management, not only creating identity on blockchain, but it also has access control over their personal information to access. So like areas impacted can be like your passports, e-residency, birth certificate, wedding certificate, IDs, online account logins, etc., etc. And digital ID can provide digital watermark that can be assigned to every online transaction of any asset. So see the use case, right? Once we get the usage, it'll be easy for us to identify which digital ID and what's the use case or what is the utility that we are going to do. So blockchain can actually give that immutability, right? So once you create a record, this record can be verified for any of the purposes. And it also has protecting the private keys, right? With blockchain, trust relies on safe keeping of the private keys in support of the truly distributed identity management. So we need to be cautious of the fact that safekeeping the sites very important. How to secure the private key? For example, cryptocurrency traders, they always say like write a piece of paper and put it for safekeeping, like you're putting it in an actual physical locker or safe deposit box, as we call it. So there are a lot of digital identity solutions. Netkey, a blockchain startup, found the digital identity solution. Released at Consensus 7, like this app can use Hyperledger to provide decentralized open source identity management. And this is also kind of approved by anti-money laundering and know your customer. This is one of the solutions, but there are thousands of solutions now available in the market on digital ID. So we saw like what are the challenges, how blockchain is actually transforming. There are various challenges, security challenges, legal challenges, IP challenges, coding challenges, and then there's also transcribing of how blockchain is changing in various industries. And we have seen some of the use cases like digital ID and the banking solutions and stuff in this chapter. So that's it. I hope you get a basic idea on the key challenge of blockchain technology. In the next session, we'll deep dive into the introduction of cryptocurrencies and more. Thank you. Welcome to this session. From this session, we'll start understanding about cryptocurrencies. So if you don't know what is cryptocurrency or don't have a clear idea about cryptocurrencies, just grab these sessions and start learning about cryptocurrencies. So we have seen what are blockchain challenges and things like that in the earlier chapter. In this section, we will be focusing on cryptocurrencies, a very important use case of blockchain technology, Bitcoin being the first use case of cryptocurrency. And actually, the blockchain started with Bitcoin. So let's deep dive into a bit of introduction to cryptocurrencies. So mining is an evaluation that actually started in the process where they can create through transaction processing that occurs every node on the network that we have seen earlier. So in 2009, one could mine 200 Bitcoins with a personal home computer. And in 2015, it would take about 98 years to just mine one Bitcoin using a personal home computer.
Today, there is almost no money to be made through traditional home mining because there is a specific circuit which has been designed strictly for mining bitcoins, that is like application specific integrated circuit. And what happened is there is a transition, like group of miners have formed mining pools for which they are relatively paid share for the contribution of the work performed. So it is completely changed. So what is the difference between currency and a cryptocurrency? Here it's backed by sovereign, that means it's a thing, and it's backed by users in terms of cryptocurrency. It's controlled by central banking system in a traditional currency, or what we call it as fiat currency. And here it is controlled by users. Easy to steal. Cryptocurrency bit difficult to hack. Hard to transport. It's very simple. Line of code. Relatively easy to trace. Here it's little anonymous because Bitcoin provides you a kind of example where you hide your identity. So what is introduction to Bitcoin? It is a virtual global currency. It's tracked in public ledger. No issuing entity, we have seen. It is traded online using peer-to-peer networks. It runs on open source protocol. That's strong encryption. So if somebody asks what is Bitcoin, it's a virtual global currency. It is tracked in public ledger. It's issuing it no issuing entity. It's traded online using peer-to-peer. It's an open source protocol and has a strong encryption. So this was somehow started in 2007 by Satoshi Nakamoto, and seen many companies in 2014 started accepting Bitcoin. So what is the technology behind Bitcoin? That's what we understood as blockchain. So you first think of Bitcoin as an electronic asset. It's a digital currency. So basically what happens is a network of computers keeps track of Bitcoin payments and keep adding to the list, and they become more and more chain. And that's what it is called as Bitcoin blockchain. The file that contains all the data is often called as ledger, and it is transacted through transaction processing. This is called mining, which is distributed through processor called nodes of the peer-to-peer network. So it's very simple. It's an electronic asset. It's a digital currency. You can actually make payments online in the blockchain using Bitcoin blockchain. It is transaction, what is called ledger, and it's processed through mining and has a distribution through nodes. Well, this is quite confusing, but basically you just have to understand how the whole thing happens. So there is a node. We have seen bit of this actually in the earlier thing, but this is a deep dive. This is just for information, a good graphic that you can just learn about it. In that you can understand what are blocks, how they have synchronized a block. What's a Bitcoin exchange? Bitcoin exchange is a marketplace where people can buy and sell Bitcoins, and they can create using signed transactions. They can have the wallet on the mobile as well, and you can have a solo miner or a mining pool, and you have basic databases on the top, which is basically distributed databases, and you have a payment engine, and you have a node that interacts with the blockchain and then keeps distributing the coins. Basically you have 6 things. Uses a distributed database. It's in blocks. Anyone can join the network, can do transaction, create add blocks, which is called block miners, and validate any of them. That is node. So if you just see the center part, that's the most important thing, and the software does it for all. So we have seen this hash function in Bitcoin. It's a public Bitcoin address by hashing the public key. It's a transaction digit for use as input for any transaction. So we have seen this. It produces a Merkle root for authenticating whether the transaction is in a block, and using hashes all the way up to the tree. And once it is approved, then it adds to the previous block to use in the block header, and then it creates nonce, and then a block that satisfies difficulty needed in mining. So we have seen this. This is just a capture of how double spending is prevented, and how the copy of the public ledger containing an audit trail of all the Bitcoin, so that you can see how much of BTC has been transacted, and what is the height, what is the time taken, and what are the transactions, what is the total BTCs in, and how much relay, and what is the size. So this is a blockchain basically. So if you just compare the protocols, Bitcoin is public, it's P2P and business to business, simple program. Every 10 minutes settlement. Ethereum, again P2P, business to business. It has programmable applications, whereas Bitcoin simple program one application and 14-second settlement. And then Ripple, it's a permission bank to bank. Basically, it's a kind of a private blockchain. A simple program, one purpose, and it's almost like a near settlement. Just we need to understand how the protocols compare between these. So let's discuss about what are tokens. A broader use is supported by the digital infrastructure through Bitcoin as represented by a token. So what is token? A token can be defined as a scarce digital asset based on underlying technology inspired by Bitcoin. So broader use is supported by the digital infrastructure introduced through Bitcoin as represented by token. A token can actually similar code databases but use different blockchain databases. So Ethereum was next to Bitcoin, and it is programmable, and tokens can be issued on the top of Ethereum blockchain. What happens is token buyers are using private keys which are similar to API keys but can be transferred to other parties without consent. You can just transfer it. You don't need a consent. So these are programmable keys. And Ethereum was the one which started with tokens can be issued on top of the Ethereum blockchain. So very popular thing. I'll tell you about ICO, which is initial coin offerings. So tokens therefore comes with a price and has a value. And tokens are a new model of technology, can be alternative to equity-based finance. Like what we call it as shares or debts or whatever you want bonds. Here you can call it as a new model. Tokens definitely don't dilute capital. They introduce a huge increase to your buyer base and time to liquidity. Tokens launches differ from equity sales. However, they can be issued as a way to share profits. Tokens can be sold internationally over the internet and are always open for business. What is the other thing? Tokens decentralize the process of funding technology. So tokens have a value. They are model of technology. Tokens do not dilute capital. Token launches different from equity sales. Token can be sold internationally, and tokens decentralize the process of funding technology. So tokens, that means like it enables a free new business model, and it introduces what is called as tech-savvy senior executive. And tokens accommodate immediate custody without an intermediary, and tokens can be extended to hardware as a part of the Internet of Things. So you have software tokens, you have hardware tokens also. And you can have Ethereum token, which can be created on the top of the Ethereum blockchain. So understand token. Tokens introduce rise of what we call tech-savvy senior executive. So nice term. Please remember that. And tokens can be issued on hardware also. These are the 2 points which you have to remember. And this is just a timestamp of how much Bitcoin volumes have done and somewhere in February, March, April 17. And what's the time closing price? Actually, Bitcoin peaked up to $23,500 last December, that is December 2017. So what are the uses of Bitcoin? It can be used for online purchases. It's a single application, like in programming. It can be used for micropayments. It gives you irreversible transactions. It can do anonymous transactions, can be invested, and you can buy anything on Virgin Galactic or airlines ticket or whatever you call it. So it basically shows that it's applicable anywhere you can use it.
So here is the end of the session. Next, we will know more about this new revolutionary digital technology blockchain works and the use cases. Hello, let's start the session with the new revolutionary digital technology blockchain, and then we will know more about it.
So we just have to go back. What is blockchain? Blockchain is the new digital disruption on the doorstep. So what happens? Blockchain is a distributed ledger technology behind Bitcoin. Just understand it. So it facilitates the movement of assets across the world in seconds with a minimum transaction fee. It has a lot of potential applications for financial asset transaction. Nothing fundamentally different for the users. Guts of the infrastructure will get revamped, and it's like they're expecting like $20 billion reduction in operating costs, especially with use of blockchain. So this is going to existing cumbersome process, but it will be drastically reducing cost of new services, and which earlier used to take days for financial transaction to reach the customers. So it's a disruptive technology. It is going to increase the visibility, massive reduction in costs, and it has potential good applications. So we also have what are called as the coins other than Bitcoin is called altcoin. So there are other alternative coins like Litecoin, Ripple, Peercoin, Next. But the philosophy of cryptocurrency usage is still evolving. Ripple is one. So Ripple is basically built on the decentralized digital currency set by Bitcoin. The function is basically connect payment systems. Basically, it works like for sending bank to receiving bank. So basically, if you understand, it's an open payment network. For example, US bank transmission, EU bank. And Ripple chooses the best USD EUR conversion rate. So that's the advantage, and it comes at a very less cost. It also comes with a currency called XRP. So that is Ripple. So it is more complementing than Bitcoin. It can allow seamless transfer of any currency. It is dollar, pound, or whatever you want, or even Bitcoins. And it allows more ways to connect with those using other forms of currency. So if you see how market positioning, 1 to 5 days is the traditional bank. Bitcoin is like up to 45 minutes. Whereas Ripple based, it's like for one conversion from US dollar to euro, it just takes 6 seconds. So see the difference from US bank to EU bank. So trading in Bitcoins, actually Bitcoin has got an ATM, Bitcoin has got online wallets. You can do over-the-counter tradings, you can do mining, you can have crypto exchanges, you can even have Bitcoins for free kind of donation. So you can do anything in Bitcoin, which we call it as a Bitcoin trading. Be it from wallet to ATMs to Bitcoins for free, to over-the-counter trades or to cryptocurrency exchanges, whatever, and including mining. And you have a lot of wallets. You have a software wallet, paper wallet, you have a USB drive wallet, you can have hardware wallets, you can have web wallets, and each one have its own function. You can have a mobile wallet. Basically, there are various ways you can store Bitcoin, but only thing is that hash value or that encryption characters, the 256 SSH characters, that 000 that we saw in the earlier one should not be given to anyone or should not be known to anyone. Otherwise, they will use your coin for their purposes. So Bitcoin mining, it's a decentralized computational process. We understood what is proof of work problem and add a new blockchain and a new block to the blockchain. It costs processing power, hardware, energy, time. So mining is basically creating a new block which earns bitcoins. So Bitcoin mining resembles the mining of other commodities. Only thing here, it requires exertion and it slowly makes new currency available at a rate that resembles at a rate which commodities are like gold or mined from the ground. So it's as slow as that and the same function it has and the same exertion it takes for a new currency to make it available. So it's very costly process. Earlier we used to know 200 bitcoins can be mined in a used home computer, but currently it is not so because so many algorithms are sitting on the mining. So how does it work? Propose a new block, then it will hit the most recent header of the block. There is a nonce that creates, and then there is a hash number, and then if it's a proof of value is done, mining is rewarded is done. Then if yes means you have a target values achieved, then you solve the proof of work. No means again incrementally keep trying. So you get a mining reward. We did see this Bitcoin transaction processing in a detailed one in the earlier chapter. So what is a major issue? Like lack of regulation is preventing big institutions from entering. No major exchanges in the US, and it is very hard to regulate decentralized, global, flexible, and though it's hard to regulate, but then decentralized, global, flexible, and they are all gaining popularity. Though regulation is not there, but still there are people who are using this. So what is a block? It is a permanently recorded transaction. Blocks organize in a linear sequence over a time on blockchain. Miners constantly process new transaction into new blocks. So what is mining? We have seen mining is a computationally resource intensive process, much like a commodity mining. So it's similar to gold and diamond, but here it is mining computationally using high compute powers. So there are decreasing supply algorithm. That means how currency will be created at what rate. So everybody, since this is an open code, people have started putting high-end qualifying algorithms. That means like to get the algorithm supply, it has created a lot of issues and it is taking more time to mine. And once the blocks are accepted only, they can never be changed or removed. So that is immutability. So once you create a block, they can get at least bitcoins. Currently, it can be identified also. And so blocks and bitcoins are created in a decentralized economy in a P2P network. As I said, this is not a formal economy. It's only survived by users. So it depends on acceptance among the users. There's no central agency movement. So what we call it as a block is a permanently recorded transaction. So just a connotation, banking is essential, banking or not, that's how Bill Gates defined. Blockchain is essential, Bitcoin is not. So this is a new way of looking at blockchain now in 2016. So 2 revolutions at the price of 1. No central authority. It's open to all. Any members can transact anonymously. So what we call it as industry level system of records, and it's a resistant digital cash. So it's a 2 revolution actually happening simultaneously. So just understand this. What are advantages? Accounts are updated, simplified infrastructure, increase visibility and cut costs heavily. So you don't need many people for authenticating and approving transactions, so the whole intermediary layer is out. So accounts are simultaneously updated, increasing speed, and it's easier to resolve disputes, and sometimes we can spot fraud faster. So cryptocurrencies, to summarize, a Bitcoin was the first digital cryptocurrency, and 21 million is what is available. Let's as with real mining, energy must be invested to small complex problems by which you can earn Bitcoins, and the most circulated are Bitcoin, Ethereum, and Litecoin. So with that, we kind of understood what are the various cryptocurrencies, what is cryptocurrency and everything.
Let's end this chapter here and see you in the next session where we will be going to cover all the popular and most important use cases of blockchain. Let's end this chapter here and see you in the next session where we will be going to cover all the popular and most important use cases of blockchain. Thank you. Welcome to this session. In this session, we will be going to cover all the popular and most important use cases of blockchain. Let's get started then.
So in this section, let's understand some of the practical use cases of blockchain and some industry use cases including financials. So these are some of the financial industry. It is between retail, banking, investment market infrastructure, asset management, insurance. This is how my knowledge is kind of divided. But then there may be some of them more, but then it includes from depository to lending to exchanges to custody to stocks to commodities to wealth management to trust to insurance to everything. So everywhere you will see blockchain getting adopted. So you will see radically changing from, for example, if you just see securities on the left side, right, it is increasing equity private markets, debts, crowdfunding, derivatives. In the smart contracts, we have seen it is giving for digital rights, escrow accounts. For industries, digital currencies, it's kind of doing microfinance, globe payments, remittances. In terms of record keeping, it is like doing healthcare, title records, ownership, voting, intellectual. So you name it, you have potential application and disruption. So this slide essentially shows that blockchain has got use cases across industries and it can change the future of transactions. Very, very important. So we have seen smart contracts. It's basically a commercial transaction which is legally approved through smart code. Smart assets, basically trade finance, supply chain, workflow, everything. Clearing and settlement, basically the short-term settlement basis. Payment, you have seen like it's going to replace the frameworks like ACH, Swift. You have seen Ripple, which can just do it 6 seconds. And it has digital identity because you can reuse the identity for many services like banks use KYC and anti-money laundering. And IoT also, because now, as I said, what is tokens can be created on hardware as well. So it's going to do mission-to-mission commerce. Financial industries using payments, private equity, bonds, derivatives, trading records, spending records, mortgages, microfinance, all are on blockchain, getting proof of concepts and stack of process, clearing networks, international transfer, auditing, reconciliation, reporting, settlement, everything is on the stack of process. Whatever the process you call it in the financial industry, what are the financial instruments that you have been using, whether it's cross-border, peer-to-peer, corporate, internet banking, everything is kind of getting used in financial industry applications best suited for blockchain. Blockchain for trading and clearing. So you have a smart contract that runs on the chain, for example, both on the chain, off the chain, and you have oracles. And we have discussed this, and they integrate with chain contracts, and then basically network participants can get it under almost like a real-time security contracts. So this is the fintech landscape. Just see the number of companies, blockchain technology growing. So you have some companies which is already there. These are some of it. Started with LHV Bank. Now you have seen Society General, Citi. I've actually shown one slide where people have started using all the JP Morgan to Citibank, how they're filing patents. So this again gives it credibility that they're trying to understand the disruption. From UBS to Santander to Society General to Barclays, everybody is trying to research on blockchain. Again, last year close to $2.5 billion have been invested in 2017. This is an old slide, but then people have become more active. Venture capitalists have become more active. They are doing investments on blockchain-based companies or startups. So why that investment interest? Because blockchain has the potential to reduce infrastructure cost. It can save money transfer up to $500 billion. And currently there are so many active fintech areas in now New York area itself. And the sector is tripling into $12 billion. So there's a huge scope, little outdated data. But the important thing that we have to essentially identify in this because investment interest has grown in blockchain. And it's kind of quadrupled to or 8 times in last 1 year. So blockchain for banking, this can be replacing letters of credit. It can be a good instrument for corporate debt. You can use it for repurchase agreements, and you can also use supply chain and self-executing B2B contracts. So it can reduce from 4 days to 1 day. It can drive 99% of the cost out into letter of credit. Corporate debt, because you just need a blockchain system so that corporate client can win the highest net discount immediately, just one API. And you can also use it as a smart contract for doing the repurchase agreements, and supply chain can actually reduce the supply chain kind of real time. So blockchain for banking consortia, you have security services, you have capital markets, you have trade finance and card operations. In security services, you have security settlement, post-trade operation and trade repository. In capital markets, you have derivative trading, derivative post-trade trade and syndicated loan. In trade finance, you have cross-border payment or cross-currency payment. And in credit card or anything, it can just do KYC. So each one has a direct share on the blockchain, basically financial services use cases. So be it from security settlement, like where it is a demat form of shared ledgers, where all stakeholders will have a direct access to the asset repository. Similarly, in trade repository, blockchain is a secure record which collects all the financial transactions. Capital markets, you can just do a trading on shares or futures or options using capital markets. Trade finance, you can do a cross-currency payment, and card operation where you can use a single KYC for getting different of all the thing in the credit cards. So where is the potential? You have potential in payments, you have in investment management, you have in market provisioning, you have in deposits and lending. So all the ways you can see the potential. This is as per the Future of Financial Infrastructure World Economic Forum 2017. So just rethinking the banking industry. So how do blockchain offers an opportunity for banks to take huge amounts of cost cut out of their back-end processing infrastructure. So a blockchain startup could be set up and offer services as quick as possible. So like, with distributed ledger, how do you gain the same trust as you have in hub and spoke system where you have a centralized process through an intermediary? So we have to rethink the whole banking industry. Another thing is why blockchain, when and how.
banks taking this very seriously because they have to rethink their value chain like never before. They have a potential for huge disruption. Blockchain is going to cut out the banks. And they are also high threat because they are giving investment and struggling to understand where to start. These are some of the questions. And blockchain is coming from 2017. It's like they say that real impact from 2020, but Morgan Stanley says that, but Barclays says that it's 10 years away, but we are not sure. Maybe as fast as 1 or 2 years. Next 5 years, where you will see the impact, payments, definitely, digital currencies, we have seen, capital markets, digital identity, and others. So, these are top 4 most inroads that can make in between 2017 and 2022, as per one of the survey. So, you have strategies to leverage, whether it's Goldman Sachs, Visa, Nasdaq, partnerships, how they are using it. So, they have gone with Santander, has gone with Ripple, Visa has gone with this chain. In-house development is happening for Nasdaq, IBM, and Citibank. And some of them are going with partnerships, like Barclays with Scalable, UBS with Clearmatics, and Litoport, Fedor Bank, and all are going in Ripple. So basically, whether you do it investment yourself, like buying a new company on blockchain, or investing in your in-house development or partnership, doesn't matter. The strategy is to invest, and the blockchain is disrupting the whole ecosystem. So how do you do that? First, 3 to 12 months. There are 6 steps or 7 steps. First, develop or publish an internal roadmap. First, understand. If you are in a trade industry, or if you are in trade finance, understand what's the business problem. Then out of that, identify opportunities to strengthen business through proactive innovation. Once you do that, you will do ongoing research to keep what's actually driving blockchain within the sector and ensure that all the staff within the are educated on development threats, opportunities in the business. Then do workshops, develop an innovation program, and start testing the technology to find what kind of solution you can provide or it can provide. So very simple. First, understand the roadmap, identify opportunities, do ongoing research, education to the key staff, and upgrade you to offer sessions and workshops, do innovation program, and finally start testing and see which use case it fits in and how it can provide. This is a recommended strategy. Long term, you can look at replacing the existing bank services with a crypto exchange, or you can give free cross-border remittances. You can also think of trading in capital markets in delays, and you can start making partnerships with other banks to set up a common platform and standard. It's something like Hyperledger. So each bank, some 10 banks to come together and then form their own blockchain. So there are some key technology players. These are some of the names which I have listed. You have CryptoCorp, if I really take your Cradle, SIG3, Third Key Solutions. You have a lot of them. Hashcurve, Cryptsy. So we have seen this hash functions. It's basically give any kind of data. It gets us a SHA-256 function. And you give a 256-bit hash value. It is like with a numerical hash tag, alphanumeric. So whether you give an image or you give a hashtag file or you give a PDF document, doesn't matter. All of them will get converted to hash value. Understand that this is only one way. You can't do reversing. So these are some of the use cases. We have seen record keeping, contracts, data, currency settlement, new ecosystems. Everything runs on blockchain. So starting from financial, you have to real estate, to logistics, to trade and finance, supply chain, internet, value, cross-border payments, escrow, identity management, auditing compliance, digital rights management. Doesn't matter. The whole end-to-end use cases have been defined. So this is one of the KYC AML with blockchain. So you already have a trusted parties. Blockchain, you can just have one place, the identification blockchain. They can be used for insurance, bank, funding, anything you want. Just have a KYC document, just upload it, and completely all faster process. Then your subscription becomes easy, whether it is for distributors or whether your currencies asset, doesn't matter. So the subscription becomes faster. Just a workflow, how blockchain can actually simplify the process. Settlement also, so you just have fiat currency, you have a bank, it all goes on a one ledger and it goes as a digital shares, and you can get a digital currency and get settled in the bank. It's all simplified subscription process. Transaction process, so you have a regulator, you have an investor, you have blockchain which stores all the transaction details, and you can also do it auditing, and you can simultaneously understand the fund. So there are continued interest that is going on. These are some of the snippets I have again got through. So this is a transaction process which I just want to go through. There's a step 1 blockchain, then step 2, which kind of transaction happens, then it's stored, then it understands between investor and the transaction, then there is a regulator who controls, and there is a fund that is getting out, and then you can do an auditing. So these are some continued interest, some snippets I've just taken from internet. Again, there's some ripple happening, so we have received this. It happens through 6 seconds between one sending bank to receiving bank, that we have shown like US dollar to euro. So some explorations that's happening in central bank. And again, some US Federal Reserve is paying close attention. So other business use cases, some people are providing blockchain as a service. Then we discussed about land registry, protecting personal data. You can have intellectual property. States like Delaware has already started using blockchain. So these are some of the resources which you can actually go through. So as per foreseeing blockchain, Bill Gates says we always overestimate the change that will occur in 2 years and underestimate that will next 10.
Don't let yourself be lulled in action. So with that, we have seen the entire thing. We started with what is accounts, contracts. We went on to what is distributed ledger technology. We have summarized key facts of blockchain. What are the challenges? We understood cryptocurrencies, and then finally we have seen some use cases. So we completely completes this module end to end.
So that's all. With the session, we'll conclude with this module. Hope you enjoyed the very first module of the blockchain course. See you in the next module, which is all about advanced blockchain concepts like mining, blocks, consensus, distributed databases, Ethereum, smart contracts, and security. Thank you.